Hi everyone, very good evening. Welcome to the class. So I hope you are in the last phase of your preparation. So there is one more week left before you give your exam. So that is the time you have been waiting for last 1 year. You have been working hard for last 1 year. So I wish you all the very best. So I wish you attempt and you answer correctly every question that you know. Okay, the questions that we don't know we can't answer, so don't expect to answer the questions correctly which you don't know. So give your best performance to answer the questions that you know very well. Okay, so that is what I wish for you. So all the very best. So be composed, be cool. So that's it regarding the preparation phase. So I hope you're all, I guess you're all very tensed. So 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 that is the state everybody will be in. So even the rankers, myself, when I wrote the gate exam also, I'm in the same phase. So being tensed means you are serious about your preparation. That is what I feel about it. So if you're really tensed about the exam, it means it's a positive thing only, it's not a negative thing. Okay, so it's not a negative thing, it's a positive thing, because you're tensed because you're serious about your preparation, you're serious about your exam, you're serious about the result that you're going to get. So don't feel bad about being tensed. Okay, so tell yourself that you have prepared well, and you're going to give your best, and you're going to get a result that you deserve. Okay, tell yourself that everything will be fine. So let us start our session. Yeah, analog communication questions for the last few years, it is same actually. Two questions, maximum three questions. Earlier it was huge weightage, like 5 6 years back it was more weightage, but last 4 5 years it's the same weightage, which is like 2 to 3 questions. But they should be easily answerable questions. Generally, the questions from analog communications are generally easily answerable, but sometimes they are making it little tricky. So in this session, I have covered all the models of tricky questions as well. So try to make the best use of this session. Okay, so try to answer it in the same way, the same way you answered in the exam. Okay, so I've given, definitely out of the 21 questions that I've taken, at least 10 to 12 questions will be tricky questions. And if you see the last 4 5 years papers, one question from analog communication also was little tricky, not very tricky, but little tricky. So they are testing your very basics, like how good your understanding is in the concept. So they have not given regular formula based questions in the last few years. Okay, so your conceptual understanding will be very much tested. So let's see how good is your preparation. Don't get tensed if you're not able to solve some questions. That's fine, completely fine. So shall we start? Hi Nitin, hi Monisha, hi Sunil Kumar, hi Deepak. So digital communication questions, maybe I might be covering in some other class, Monisha. So for this session was scheduled as questions based on analog communication. So I'll be focusing only on all the models of questions possible on analog communication. Okay. Hi Kranti, hi Sai Kumar. So are you ready? So 21 questions. I'll wait for 2 to 3 minutes, and after that I'll be solving in my own way, or the best possible way. If you can solve it in a better way than me, you can let me know. Okay, right. So let's start. Let's go with the first question. Think carefully and answer. Think carefully and answer. I would rate this as an intermediate level difficulty question. If anybody has got the answer, you can answer. You can type it in the live chat. If you are a 2-digit ranker, then you should have answered it by now. Is there any 2-digit ranker here? You should be able to answer this question within a minute. You don't need to put your pen. Understand the question carefully. Yeah, there comes a two-digit ranker. Very good, Sunil Kumar. Very good. Very good, Pallavi. Your guess, Sai Kumar, is it your guess or are you confident about it? Come on, you should not guess, okay? It's not lottery to guess. You should be certain. Wonderful. Excellent. Many of you have answered correctly. I appreciate it. Right. Very good. So let me answer it. An AM modulated signal, you know what is an AM modulated signal, whose carrier frequency is 400 kilohertz, which means they have given us the carrier frequency of C, and they're saying that AM modulated signal has frequencies 408 kilohertz, 415 kilohertz, and 420 kilohertz. There are three frequencies regarding message. Okay, generally we discuss in the class about in analog communication only single tone modulation generally, but this is not single tone modulation. There are three tones in this, three frequencies in the message. Okay, so if you plot the spectrum, it is going to look something like this. It is going to look something like this. Because it is AM signal, there will be an impulse at 400 kilohertz, right? And they are also saying that we are having an impulse at 408 also, and we are also having impulse at 415 and 420 also, because they are saying that we are having those frequencies. So what are the amplitudes of those impulses? That is not given, so we can take any amplitude that we wish for. So this frequency is 408 kilo, and this frequency is 415 kilo, and this frequency is 420 kilohertz. Now since it is AM modulation, so these are all upper side bands. They did not give us some information, but because they have said that it is AM modulation, we also will be having lower sideband components also. Correct or not? Whether they asked you or not, you have to analyze completely. My second question will be based on this analysis only. So there will be another impulse which is symmetric to this, and there will be one more impulse here, and there will be one more impulse here. Can anyone tell me the locations of these impulses? Can anyone tell me the location of these impulses? Anyone? So this is 408, right, which is 8 kilohertz from here. So another impulse will be 8 kilohertz on the left side also, which means this will be at 392 kilohertz. For this question, to answer this question, plotting these impulses is not required. Many of you have done it without plotting the impulses. That's very good, actually. That's not required. But your visualization should be like this. Then if there is any tough question also, you'll be able to answer it. Okay, how about the next one? Can anyone tell me the location of this impulse? So this impulse is symmetric to this one, the second one here. So this is the upper sideband, and corresponding lower sideband is here. What is the location of it? It is at 15 kilohertz from here. From the carrier, it is at a distance of 15 kilohertz. So this will be 385 kilohertz. Wonderful. And how about this one? This is the one symmetric to this one. So it is at a distance of 20 kilohertz from the carrier. So which means in the 20 kilohertz on the left side, this will be 380 kilohertz. Very good. So now can you tell me the bandwidth of the AM signal? Bandwidth of the AM signal is highest frequency minus lowest frequency. And how much is that? 420 minus 380, which is 40 kilohertz. You don't need to plot it actually. You don't need to plot it. But if this plot comes in your mind, that means you are thinking amazingly well. You don't need to plot it, because I'm explaining you, I'm plotting. If I'm doing it myself, I'll be visualizing. Okay, where are the impulses? Okay, this side there will be some impulses. What is the location of those impulses? All those things should pop up in our mind. Okay, very good. So many of you have guessed. Okay, 408, 415, 420 is the highest. So lowest will be 400 is the carrier frequency. Highest is 420. Lowest will be 380. You might have guessed. Okay, highest is 420. Lowest is 380. Bandwidth is highest minus lowest, which is 40 kilohertz. Yes, your guess is perfect. That is right. Shall we go to the next question? Or before going to the next question, let me ask you some more questions here. Okay, let me ask you some more questions that are possible here. Can anyone tell me what are the frequencies in the message signal? In the message signal, what frequencies are present in the message signal? What frequencies are present in the message signal? Can anyone answer this? frequencies in the message? Anyone? Can anyone answer this? What frequencies are present in the message signal? Come on. Anybody can answer this? It's an easy question. Very good, Sunil. Very good. That's very good. So what are the frequencies? From carrier frequency, we have an impulse at 408 kilohertz at a distance of 8 kilohertz, which means original message should have been 8 kilohertz frequency. And we are having an impulse at 415, which is at a distance of 15 kilohertz from 400, which means the second frequency that is present in the message is 15 kilohertz. And there is third impulse at a distance of 20 kilohertz from the carrier, so which means there is a frequency 20 kilohertz frequency also. So message is having three frequencies: 8 kilohertz, 15 kilohertz, and 20 kilohertz. Okay, from this also you can answer this question. If message highest frequency is bandwidth of the message is 20 kilohertz, so bandwidth of any modulated signal is 2 times of message bandwidth, which is 40 kilohertz. Shall we move on to the next question? Are you ready? Are you ready for the next question? Shall I move on to the next question? Yes, no? Very good. Okay then. So I'm moving on to the next question. So be ready. I want your answer within 2 minutes. Within 2 minutes. As fast as possible. Come on. Here comes your second question. Here comes your second question. We've already answered this question in the previous slide. If you have observed, we have already answered this question in the previous slide. Come on. D. Many of you are saying D. Is it right? Are you confident? Anyone? Any other answers? Or is D only? All of you are sticking with D? Oh my god, many of you are answering the same thing. That's very good. But your answer is wrong. But your answer is wrong. Can anyone identify your mistake? Can anyone identify your mistake? Anyone? Have you identified your mistake? Very good, Pawan Kalyan, Pallavi. Now you got your answer. C is the answer. Why did you forget the carrier frequency? See, a modulated signal has a carrier whose carrier is 400 kilohertz. Has frequencies. What frequency I'm saying it is having? 408, 415, and 420. These three frequencies I'm mentioning. What are the other frequencies that are present? See the previous slide. See the other. I'm mentioning only these three frequencies, right? So these four frequencies I'm not mentioning. No, 380, 385, 392, and 400. Four frequencies. Okay. So the mistake, the silly mistake that you have done is you forgot the carrier frequency part. Okay. Because you have to pick the best option. So which option is the best one to pick? Option C is the best option to pick. Right? Option D is also correct, which is more correct. Option C is more correct, right? Yes. So don't make these silly mistakes. These are the silly mistakes generally we do. Though we know the question, we make such silly mistakes. You have to be careful. When you are picking up an option, see other options also. Quickly graze the other options. If any other option is close, then try to carefully think if that answer is that a possibility or not. Okay. Whenever you are picking an option, just have a quick look at the other options also, and then decide if you are making any silly mistake. Okay. Try to avoid this mistake. This is the most important mistake that everyone makes. The minimum mistakes that you make, the minimum number of mistakes you make such mistakes, then you will be getting the maximum number of marks. Wonderful. So I'm moving on to the next question. Many of you have made one mistake. That is silly mistake. That's not your conceptual mistake. That's a silly mistake. That's fine. I'm moving on to the next question. Be ready. This is an easy question. I want your answer within a minute. I want your answer within a minute. I want your answer within a minute. Come on. You can do it. It's an easy question. The difficult questions are yet to come. They will come. I'll challenge you with those questions. In the exam, if you're not able to solve tough questions, that's fine. But we should not leave any easy question. We should make sure all the easy questions are answered correctly. Hi, choose smile in gardening. What a name. Very good. So, anyone? Some are saying B, some are saying C. What is right? Easy question. It's an easy question. Just recollect things carefully. B. Some of you are saying B. One minute is over. Come on. So now I'll do it. Okay. I'll do it. B is the right answer. Very good. Very good. So what is given? Carrier frequency is given, which is not required to solve this problem. And if modulation index is given, mu is 50% means mu is 0.5. When modulation index is given as percentage, it means mu is multiplied with 100 and told as percentage. Okay, whether it is given as percentage or without percentage, it's okay. You should be able to understand it. Okay, 0.5 will be given as 50% sometimes. Yeah, sure. I want you to see that option. One option will not be visible if I'm at the center in my position. So that's why I'm moving this side and that side. Anyway. So what is the question asked? Ratio of power at carrier frequency. Power at carrier frequency or power in the carrier divided by total power. Whenever they give you this kind of questions, just follow the simple rule. First, let me write the formula for total power. What is the total power formula in A modulated signal? It is PC into 1 plus mu square divided by 2. Right? So efficiency is equal to, when they don't mention any message signal, you can take it as, you can assume it is single tone modulation, and you can use the formula for single tone modulation. Right? So what is the, it's not about efficiency here. So it is PC plus mu square divided by 2 into PC. Okay. So this is the carrier power. This is the carrier power, and this is the sideband power or message power, you can say. After modulation, the amount of power that is in the message part. So what they're asking is power at FC. So replace power at FC with PC. What is the total power? Total power formula is PC into 1 plus mu square by 2. Whenever they give you this kind of formulas, ratio of powers or anything like that, just take this formula, divide this into two parts, then you'll understand what is the carrier component and what is the sideband component and what is the total component. So whatever ratio they ask you, try to substitute in these terms, then it will be easy. So PC cancelled, it will be 2 divided by 2 plus mu square, and mu is given as 0.5. You can substitute that here, 2 divided by 2 plus mu square is 1 by 4. I think answer is wrong, I think I have not given the options perfectly. 4 plus 8, 2 into 4, 8 by 9. Is that right? 8 by 9. Power at carrier frequency divided by total power. Yes, it is, answer is 8 by 9. My mistake in the options. It should be 8 by 9. It should be 8 by 9. Okay, so I've given one more question. Actually, I've given one more question. So I think those options I have rewritten for this, but the answer is 8 by 9. Option B is the right answer. Okay, So if the question was ratio of power at FC divided by power in sidebands, then the answer would be 8. Power in sidebands or message, then it is PC divided by power in sidebands is how much? Mu square by 2 into PC, which is 2 by mu square, which is equal to 1 divided, sorry, it is 8. Correct? Huh? Why did some of you have done a mistake? I think some of you have not answered because the options are not matching. I think some of you might have done correctly because the options are not matching. You might be in a confused state maybe. Okay, so it's my mistake to check the options once again. I've given one more question in on the same question. Okay, I mistakenly I did not write the right options. Anyway, I hope the question is clear and the answer is clear now. I'm moving on to the next question. If you're having any confusions, you can stop me. Ready for the next question? I'm going to the 4th question. Good. I'm going to the 4th question. Let's see how fast you'll answer this. Come on, no mistakes. No mistakes. No silly mistakes. Option B is 1 by 8. Option C is 1 by 8. I think you are not able to see that. Come on, you should do it correctly. Come on, Nitin. Come on, Manisha. I want a very quick answer. Deepak. Sunil, come on. Come on. Don't make any mistake, okay? I've tried to confuse you here. Let's see how many of you will get confused. Okay. Are you certain, Pavan? You're guessing. Are you sure? Nasreen, Kishan, is it D? Very good. Many of you have answered it perfectly well, and the answer is 8. Read the question. I've tried to confuse you. The questions will be like this only. In the exam, we'll feel that after the exam, we'll feel like we have done a silly mistake, though we know all the concept. Right. Try to understand the question. Find the ratio of power at carrier frequency. Similar question as the previous one. A small change. Power at carrier frequency divided by power at 760 and 780, it seems. Power at 760 and 780. Power at 760 kilo plus 780 kilo. These two together. This is what they're asking. So try to understand immediately. Spectrum should come to your mind. Immediately. Our carrier frequency is at 800 kilo. And what are the other frequencies? 760 and 780, it seems. We're having impulses at 760 and 780. 760, 780. But since it is aim signal, we should know that there are impulses at on the right hand side also of the carrier. So it means what they have given is the frequencies given are lower than the carrier frequencies, which means they have given us the lower sideband components, the location of lower sideband components. How about the upper sideband components? It is 820 kilohertz and 840 kilohertz. I hope you understood this. Okay. Now they're asking us about, in the denominator, they're asking us the power of only lower sideband components. So always go to the general formula, Pt equal to Pc into 1 plus mu square by 2, which is Pc plus mu square by 2 into Pc. This is total sideband power. This gives us total sideband power. Just use this formula only for any kind of questions like this. So power at carrier is Pc divided by, what is the power in the, no, they're not asking total sidebands, they're asking us only about lower sidebands. Lower sideband power is half of total sideband power. Lower the 760 and 780 together, we call it as lower sideband. What is the power in the lower sideband components? It is half of the total sideband power, which is mu square by 4 into Pc. I hope everybody has understood this part. So PCBC gets cancelled. It is 4 divided by mu square. Now mu is 0.5. You can substitute that. Mu is 0.5. 1 by 2 whole square is 1 by 4. Oh my god, I think many of you have answered wrongly. Even I said that B is right. It's my mistake. It's 1 by 4, which is 16. Come on, how come many of you have answered wrongly, including me also? I thought 8 was right. It's not 8. It is 16. Come on, many of us has done silly mistakes, because I think many of you are influenced with the previous question, right? In the previous question 8 was there. We marked 8, so we are attracted towards 8. So I think many of you have answered 8. Even I thought 8 was the answer because I solved it previously. I remembered 8 in my mind, so I thought it was 8, but it was not 8. So the answer is 16. Correct? Nitin, so I'm specifically asking 760 and 780 because the other frequencies are at 820, 840. The other frequencies are 820, 840. I'm not asking about them. No, I'm not talking about in the denominator. I'm not talking about other frequencies like 820 and 840. Okay, fine, Bharat. Okay, is that fine? Any questions here? Are you fine with 16? Everybody still standing on B? 8? No, right? Okay, so shall I move ahead? The answer is 16. I don't know what silly mistake you have done. Okay, I think you might have taken total sideband power. That is a silly mistake everybody takes. So that's what I told you. I have tried to put a trick here. So the mistake many people will make, I have tried to exploit that mistake. So you have done the mistake. So be careful next time onwards. Are they asking about total sideband power, or they are asking about only lower sideband power or upper sideband power? Be careful about that. Okay. Shall I move forward? I'm going to the 5th question. Be ready for the 5th question. Come on, this is a very good question. Very good question. Similar model has been asked multiple times in the previous year papers. If you have done a similar model, it will not take more than a minute. Questions on analog communication, most of them are easier only. It is possible to frame tough questions, definitely. It is possible to frame questions that can take time, but since in GATE exam generally they will frame questions which are logical and which will take less time if we observe carefully. Generally such kind of questions are framed. Are you able to observe the signal? It's not DSB signal. Try to understand this. It's DSB signal with full carrier, which means DSBFC. DSBFC they're saying, which is AM signal. They're talking about AM signal only here. We are talking about AM signal. Okay, so AM modulated signal is given. This signal, if you observe, this is the AM signal. And if you see the envelope is sinusoidal, which means message is sinusoidal. Whatever is the envelope, whatever is the shape of the peak amplitudes, that is the shape of the message. This inside signal, that is the modulated signal. That is the modulated signal. So what is the maximum amplitude of the modulated signal? That we call it as A max. So let me write the equation here. AC into 1 plus Ka m of t into cos omega ct. So this is the general equation of a amplitude modulated signal. So if you take a sinusoidal case, single tone case, which means if the message is sinusoidal, then what happens? It becomes AC into 1 plus mu cos omega mt into cos omega ct. So why am I taking like this? Can I take like this? Is it okay in this problem? If nothing is given, I can take it. But in this problem, message is given, message shape is given, and the message shape is also sinusoidal. Message shape is sinusoidal. So can I take like this? I can definitely take like this because message shape is also sinusoidal. If the message shape is not sinusoidal, I should go with the general formula. Okay, wonderful. So now can you tell me what is the maximum amplitude of S of t? Let me call it as A max. What is the maximum amplitude of S of t? It is possible when this cos is max and this cos is also max. and that when that happens, it is AC into when cos is max, when it becomes 1, and that in that case, when this becomes 1, it becomes 1 plus mu, and this also becomes 1. When both of these two becomes 1, that is when we get the maximum amplitude, which is AC into 1 plus mu. And what is the minimum peak possible? Maximum peak possible in the modulated signal is AC into 1 plus mu. Minimum peak is possible when this takes minimum value. When this takes minus 1, that is when we get the minimum positive peak. I'm not talking about negative peak, minimum positive peak. So this is also positive, this is also positive, but minimum positive peak. I mean, I'm talking about this one. Minimum positive peak, maximum positive peak. This is A max, which is 150, and this is A min. In this problem, A min is given as 30 and A max is given as 150. A max is given as 150, A min is given as 30. Do you remember the formula for mu? If you don't remember the formula for mu, that is also fine. That is also fine. So, do you remember what is AC formula in this case? AC is the midpoint of A max and A min, correct? If you don't remember any formula for that, that is also fine. See this one? A max and A min, if you add, what happens? See? A max plus A min, if you add, what happens? If you add these two formulas, mu part gets cancelled. No, it becomes 2AC. Correct? So if you want AC, just add A max and A min and divide it by 2. What I mean by that is, if you know A max and A min, maximum peak amplitude and minimum peak amplitude of A modulated signal, then just the midpoint of both of them, midpoint of the A max and A min, that itself is the carrier amplitude. And how much is that in this case? AC in this case is equal to 150 plus 30 divided by 2, which is equal to 180 by 2, which is 90. Midpoint is 150 and 30 is 90. 90 is AC, carrier peak amplitude. Okay, so we got that. So we know AC, and if you know AC, I think we can find mu. Correct? In this formula only you can substitute AC, which is 90, and we know A max, and we can find mu. That is one way. If you don't know, remember any formula, in that case you can use this. There is a formula also, we can use that formula as well. I'll tell you that formula also. But before, so A max is 150. I'm just substituting this formula. A max is equal to AC into 1 plus mu. AC is how much? 90 into 1 plus mu. I'm substituting what I know. A max we know, which is given. AC, that is not given, but we have found out using our basics. So 1 plus mu is equal to 150 divided by 90. 0 cancelled. So 3 5s, 3 3s. So mu is equal to 5 by 3 minus 1, which is equal to 2 by 3. Is that okay? I hope everybody has solved. I think many of you have solved using this formula. If at all, if you forgot the formula, I wanted you to solve it without formula also. That's why I've solved it in this way. But if you have used the formula, it would have been hardly half a minute, not more than that. There is a formula using A max and A min, which is mu is equal to A max minus A min divided by A max plus A min. So this is the formula that we can use to find mu, which is equal to, what is A max? 150 minus A min is 30 divided by A max is 150 plus A min is 30, which is equal to 150 minus 30 is 120 divided by 180, which is again 2 by 2. So I think most of you have done it like this. That is fine, perfectly fine, perfectly fine. If at all, if you forgot, yes, you can come from the basics like this. Okay, I hope it is clear. Very good. So till now, easy questions. Next comes tricky question. Next comes a very tricky question. Very tricky means it's not like out of the box, but you have to use your basics properly. Let's see how many of you will answer that. Next question will be challenging. It will be challenging. Let's see how many of you will answer. So what is the answer? Answer is 2 by 3, which is 0.66. Many of you have answered it correctly. Very nice. I'm going to the next question. Sixth question. The figure is same. I think you have already done some analysis in the previous slide. You can use the same analysis. I'll just recollect what analysis we have done. You also can recollect. I'm not doing the question. I'll wait for 2-3 minutes. I'm just recollecting what we have analyzed in the previous slide. A max is 150. A min is 30. Very good. Now they're asking us the total power of modulated signal. What is the total power of modulated signal? That is an easy question, I guess. Anybody can do it. Total power of modulated signal is equal to PC into 1 plus mu square by 2. That is an easy question. The second part of the question will be the tricky part. I think you can answer the first question very easily. Carrier power is PC is AC square by 2. R you can say AC square by 2 R you can write. Since R is not mentioned in the problem, you can take it as 1. Whenever R is not mentioned, you can take it as 1. And we have analyzed in the previous slide what is AC. AC is the midpoint of Amax and Amin, which is 90. We have calculated in the previous slide. It is 90 square divided by 2 into R is not given, so we can take it as 1 into 1 plus. What is the mu value? Earlier we have found the mu value. Mu value is 2 by 3, right? Correct. Mu value is 2 by 3. 2 by 3 whole square is 4 by 9 divided by 2. 4 by 9 divided by 2, which is equal to, it is 8100. 90 square is 8100 into 1 plus 2 by 9 divided by 2. So it will be 4050 plus 900 plus 900, yeah. It is 4950. I think many of you might have got this answer already. 4950 watts is the answer for the first part of the question. Since that part is an easy question, I've answered it already. Second part is the tricky part. I'll wait for the second part. Let's see how many of you will solve it. Come on, make it quick. 4950, option A, option B, option C. There is no possibility of eliminating the options because 3 options we are having the same answer, 4950 watts. So only option D we can eliminate. Other options are there. So we have to solve the second question. There is no way of eliminating the second option, eliminating options. Second question should be compulsorily solved. Read the question carefully and try to answer. Kishan, is it B? Yes, man. I think wonderful. That was really quick. That was really quick. Amazing. Very good, Pavan. Very nice. If you have answered the second question this fast, you are amazing. No doubt about it. South, check your answer once. South, if you have done any calculation mistake. Second question, second part of the question is not simple and straightforward. We have to think carefully. You have to apply your basics properly. Very good. If you have got to 10, I think that should be the right answer as far as I remember. Okay, anyway, let me solve it. I think 2-3 minutes is already over. Let me solve it. If whoever has not got the answer or whoever has got the answer also, just look at it carefully. You might have solved it in a different way, or you might have solved it in the same way as I have solved. But just look at whatever I'm doing. So mu initially was 2 by 3, right? and we have changed the mu value. We want to change the mu value. So read the second part of the question. The amplitude of the additional carrier which must be added to the waveform to attain a modulation index of 20%, it seems. Which means we want to change the mu from, let me call it as mu dash. Okay, the new mu value will be 20%, it seems, which means 0.2. And how are this doing that? By adding the carrier, by adding an extra carrier, AC dash cos omega ct. For this signal, they are doing plus AC dash cos omega ct, it seems. For this signal, they are adding an extra carrier. What happens when you add extra carrier? Modulation index will decrease, no? Correct? So as you add extra carrier, what happens? Carrier component power. Carrier power component will increase. As carrier component power component increases, efficiency decreases, no? Efficiency means what? Message power divided by total power. Message power divided by total power. If you increase the carrier power, what happens? The denominator increases in the efficiency, right? So efficiency will decrease or modulation index will reduce, right? So by adding that extra carrier part, which means they're increasing the carrier component. So by adding extra carrier component, they are trying to reduce the modulation index. So now they're asking us to find out how much should be the amplitude of the additional carrier, which means they are talking about in this notation that I've taken, they are asking us to find out the AC dash, the carrier component, that extra that we are adding, that carrier component's peak amplitude. Okay, AC dash is what they're expecting us to find. AC dash is what they're asking us. So basically here S of t equation is AC into 1 plus mu cos omega mt into cos omega ct. Now what they are doing is they're adding extra carrier, and here, so what is the equation? Now S dash of t, let me call it S dash of t, let me call it. The new equation is AC into 1 plus mu cos omega mt into cos omega ct plus AC dash cos omega mt, sorry, cos omega ct. So this is the new equation, it seems. This is the new equation. Now graphically, I just want you to understand what happens mathematically. So that is what I have written. I'm just trying to explain the question till now. I did not solve the question. Okay, I did not solve the question. So when you add this carrier, could you tell me what will be the new Amax? Could you tell me, anyone can tell me Amax dash? What is the new Amax value? Earlier Amax was 150. Okay, earlier Amax was 150. What is the new Amax value? Anyone can tell me this? When you add a sinusoidal signal, when you add this carrier AC cos omega ct to this signal, this inside signal, this signal, what happens? Every peak will increase by AC dash, no? Maximum peak also will increase by AC dash. Minimum peak also will increase by AC dash. You can do this problem in multiple ways. Okay, you can do this problem in a multiple ways. Whatever idea you get, you can implement that. So I'm doing it, trying to do it graphically. So what is Amax? 150 is the Amax value earlier, before adding the carrier. After adding the carrier, what will it become? It will become AC 150 plus AC dash. See this one? What is the max value possible here? That is what I'm asking you. Mathematically also you can see. What is the max value possible here? AC into 1 plus mu. When this cos becomes 1, it becomes AC dash. The max value possible here is AC into 1 plus mu plus AC dash. So that is what I have written. Could you tell me what is A min after adding the extra carrier? What is A min? Anyone can tell me this? 30 is the A min earlier, before adding the carrier. After adding the carrier, it becomes 30 plus AC dash. See this one? A min happens. Minimum positive peak happens when this cos message amplitude becomes least value. When this takes minus 1, it becomes AC into 1 minus mu plus AC dash. So which is 30 plus AC dash. Is that okay? If you know Amax and A min, we know the formula for mu, right? New mu is 0.2. The formula for mu is Amax minus A min divided by Amax plus A min. We can use that formula, or if without that formula also you can do, not a problem. Any procedure is fine. Whatever idea you get, you can implement it. It will not, hardly 10-15 seconds difference will be there, not more than that. So I'm putting a dash here because I'm talking about the new mu value, new Amax value minus new A min value divided by Amax plus A min. Okay, so shall we substitute that? So what is the new Amax value? 150 plus AC dash. And what is the new A min value? Minus of 30 plus AC dash divided by 150 plus AC dash plus 30 plus AC dash. So here AC dash gets cancelled, and mu value is how much? 0.2, right? Mu value is 0.2 is equal to 150 minus 30 is 120 divided by, this is 150 plus 30 is 180 plus 2 times AC dash. Fine. So which is equal to 120 divided by 2, I'm taking common, which is 90 plus AC dash, which is equal to 60 divided by 90 plus AC dash. So you can send this 90 plus AC dash onto the other side. What happens now? 90 into 0.2 is 18 plus 0.2 times AC dash is equal to 60. 0.2 times AC dash is equal to 60 minus 18, which is 42, right? AC dash is equal to 42 divided by 0.2, which is equal to 42 divided by 2 into 10. 420 divided by 2, which is 210 volts. I guess you have understood it. You need not apply the same formula. Earlier there are formulas for Amax and Amin also. You can apply them also. You can try other possible ways of doing the problem also. This is not the only way to do the problem. You can do it other ways also. You can take a different assumption also. Instead of AC dash, you take some other notation also. That is also fine. Power calculation. Okay, sure, definitely. I hope everybody is clear with this part. This is a tricky part. This is a little tricky question. Okay, so you try to do it on your own once again, if at all, if you have not solved it now. If there is any small misunderstanding from your side, just try to do it on your own. Once you do it on your own, you'll understand what you are lacking, what you did not understand. Okay, so power calculation. So what is I don't know what is confusing here, Nitin. Power calculation, PT is equal to PC into 1 plus mu square by 2. That is the formula. I'm using mu square by 2 formula because I'm talking about sinusoidal signal. I'm using sinusoidal signal. Somebody is spamming the live chat. Fine, don't worry, ignore it. Right. So this is the formula. So PC is carrier power. Carrier power formula is AC square by 2R. Okay. So AC is not given in the question, but we have to find it. We know Amax and Amin. From Amax and Amin, we can find AC, which is 90. That is what I've substituted here. Mu value is 2 by 3. We have substituted that. I think there will be small confusion here whether I have to use the old mu value or new mu value. So initially the question is, they did not say that mu value is changed, and after that they did not ask the power. First they have asked the power, and then they said what is the new amplitude of carrier that should be added so that mu will be changing. Okay, so that's why they're asking us about the power before changing the mu, before adding the carrier. Is that fine, Nitin? Anyone else have any questions, any confusions here? Quickly let me know. Mu value. Okay, so mu value, this problem is previous problem only, no? So I've taken the mu value directly, or else if you want you can calculate it also. We can calculate it also. Amax minus Amin divided by Amax plus Amin. If you apply, you'll get the mu value, which is 2 by 3. You can, I'm substituting that 2 by 3 here. Okay, I think I have given you a tricky question, little tricky question. So many other tricky questions, little bit tricky questions are going to come. Wait for it. So shall I move on to the next question? 7th question. Ready? This is a very good question. Not very tough, but little different from the regular problems. Little different. Read the question carefully. First, understand the question correctly. Understand what they have given and understand what they are expecting us to find. First, when you are clear with those two things, what is given and what should be found, then half of the problem is done. Come on, make it fast. You can do it. Little different from the regular questions, but easy question only. Should be done within 2 minutes. A little bit of calculation is involved, but you should be able to do it within 2 minutes. Come on, who will tell me the answer? So this is the most important statement. This is the statement which, if you can understand, the question is done. Read this statement carefully and try to understand it. There is a message signal. Using this message signal, they are doing SSBSC modulation, it seems. Single sideband suppressed carrier is used as modulation scheme with carrier frequency of 200 megahertz. Then bandwidth of the modulated signal. What is the bandwidth of modulated signal in SSBSC? Bandwidth of modulated signal. Bandwidth of SSBSC modulated signal is equal to bandwidth of message only. No, it is same as bandwidth of message. The same as bandwidth of message, right? So if you can find the bandwidth of the message, your problem is done. Simply they are testing your Fourier transform basics, nothing more than that. Very good, Kishan. Very good, very nice. I think as far as I remember, root 6 should be the right answer. So you just need to find the bandwidth of the message, and if you want, whenever you want to find the bandwidth, what did I tell you? If you remember, if you have attended my previous classes, or if you have not attended also, that is fine. Whenever you want to find the bandwidth, you should know the Fourier transform. If you can know the Fourier transform, bandwidth calculation is very simple. Okay, so m of t is given, so you just need to find m of f. M of f. What is m of f here? It is in the format of e power minus at into u of t. It is 1 by Fourier transform is 1 by a plus j omega. Correct? 1 by a plus j omega, pi plus j omega. Correct? I hope everybody got the same Fourier transform. It's a very simple Fourier transform. 1 by pi plus j omega is the Fourier transform. Now if you plot this, if you plot the magnitude characteristics, it is decreasing both sides like this. It has a lot of frequencies, okay? It has, ideally speaking, it has infinite frequencies. So what should be taken as bandwidth? Generally we take it as 3 dB bandwidth. Generally we take 3 dB bandwidth, but in this problem, that is the trick that they are playing with us. Try to understand the trick they are asking, that playing with us. The maximum frequency present in this signal is decided up to the point at which magnitude becomes one-fifth of the maximum value. What is the maximum value here? Maximum value happens at f equal to 0. Maximum value happens at f equal to 0, correct? Because as omega increases, overall value decreases. So it is decreasing both sides. How did I plot the diagram? I don't know the exact shape, but I know that as omega increases, denominator increases and overall value decreases. I'm plotting the magnitude only. I'm plotting only the magnitude part. I'm not plotting the phase part. Since I know that it is decreasing both sides, I'm plotted some shape which is decreasing both sides. Okay. You can plot any shape. If you have plotted different shape which is decreasing both sides, that is fine. Now, what is the maximum amplitude of the Fourier transform? Well, it happens when omega equal to 0, and that is how much? 1 by pi, correct? Maximum amplitude happens at m of f equal to 0, which is 1 divided by pi plus 0, which is 1 by pi. And they're saying maximum frequency present in this signal is taken as 1/5 of the maximum amplitude, it seems, is taken up to the point where the amplitude becomes 1/5 of the maximum value. What is 1/5 of the maximum value? Can you tell me? 1 by pi is the maximum amplitude. 1/5 of this is 1 by pi divided by 5, which is 1 by 5 pi, correct? So there is some frequency at which the amplitude becomes 1/5 of the maximum amplitude, and this is what is the highest frequency they are assuming. If they are assuming the highest frequency in the signal as this point, this is what we can call as bandwidth B. You can take any other notation also. So this is the highest frequency they are assuming. Highest frequency in the message is what we call as bandwidth. So this is the point that they are asking us to find. So that will be our answer also. Okay, right. So let us find this. So as a function of f, I have written it as a function of f. Okay, and they are also asking the bandwidth of the modulated signal in hertz. So since we are dealing in hertz, try to deal it in terms of f. Fourier transform, you can deal in terms of omega. You can also deal it in terms of f. So it's better to deal in terms of f. F is more convenient. Okay, now what is the at frequency f equal to B, at frequency f equal to B. What is the amplitude? What is the magnitude? The magnitude is 1 by pi plus j. What is omega? Omega is 2 pi f. Omega is 2 pi f. What is f value that we are interested in? At B, f equal to B, we are interested in the magnitude. And how much is that magnitude? We were interested in the magnitude, so that's why I'm applying modulus, which is equal to 1 by 5 pi. 1 by 5 pi. So this implies, what is the magnitude here? It is 1 by under root of pi square plus 4 pi square b square, which is equal to 1 by 5 pi. So if I square it on both sides, it becomes 1 by pi square plus 4 pi square b square is equal to 1 by 25 pi square. Pi square you can cancel on both sides, and what remains is 1 plus 4b square is equal to 25. Denominators I am making it equal. So 4b square is equal to 25 minus 1, which is 24. B square is equal to 6, which is b is equal to under root 6. Since it is as a function of f, it is root 6 hertz. If we are dealing in terms of omega, the unit is radians. So radians per second. The unit of f is hertz. So answer is root 6 hertz is the bandwidth of the signal assumed. Bandwidth of the signal is assumed as root 6 hertz. Since the bandwidth of the signal is root 6, bandwidth of SSBSC modulated signal also will be same as bandwidth of the message. So the answer is root 6. I guess you have understood. A small calculation is involved here. You just need to understand this statement. If you have understood this statement, this question is an easy question. Understanding this statement is the most tricky part here. Okay. I hope it is clear. If they have not given that statement, then what we would have taken as bandwidth generally? If nothing is given for a signal like this, which has infinite frequencies, generally we take 3 dB bandwidth. 3 dB bandwidth means the frequency at which the magnitude becomes 1 by root 2 times. So 1 by pi divided by root 2. That is the point where the magnitude becomes, you can say that at some frequency here, it becomes root 2 times 1 by root 2 pi at some frequency. This is what we call as 3 dB frequency. For a signal like this, there are a lot of frequencies. What range should be taken as bandwidth? That we are not sure. So for signals like this only, we have introduced something like 3 dB bandwidth, 6 dB bandwidth, something like that. Generally used bandwidth is 3 dB bandwidth. In this problem, instead of 3 dB, they have taken some other bandwidth. I hope it is clear. So it is a little tricky question. So you should be able to. This is a question based on Fourier transforms plus communications. I hope it is clear. So I'm moving on to the next question. Try to solve it on your own again after the class. Then it will be more clear. If at all, if there is any slight confusion, do it again. Do it on your own. Okay. Right. I'm moving into the next question, 8th question. Let's see how many of you will solve this one. Very good. So this is a question. This is a question which is based on very basics. Very good question. You can just look at it and answer it. There is no need to put your pen also. If you know the concept of amplitude modulation very well, then you can answer it just like that. How many of you will answer this? How many of you? Let's see who will answer first. Write the general equation. Write the general equation and try to understand. AC into 1 plus Ka m of t into cos omega ct. So this is the general equation. So now they're asking us to find out, they're talking about modulation. They have given us a modulation index. Okay, modulation index. So what is the formula for a modulation index? Mu is equal to Ka into mod m of t max. That is the general formula for modulation index. We will write it as Ka into am only for sinusoidal case. This is the formula valid only for single tone modulation or sinusoidal message. But the general formula is this. Okay. So let us just apply this one. No. So mu they have given it as 0.5 because they are saying that it is 50% modulation. Okay, and Ka into m of t, in place of Ka into m of t, what we are having is this part. We are having this part, this part, this part. There are three options in place of Ka into m of t. Ka into modulus of m of t is given, it is 1 by 1 plus t square, 1 by 1 plus t square. So what is the maximum value possible here? So can anyone tell me what is the maximum value possible here? What is the maximum value possible here? Because the denominator is a function of t, as t increases, overall value decreases, which means maximum value happens at only at t equal to 0. This is maximum at t equal to 0. I hope you agree with this one. Can you, everybody will agree with me on this? When t equal to 0, we get the maximum value for a message signal. Message is maximum when t equal to 0. At t equal to 0, it is 1. At any other time value, m of t is less than 1, right? So it is Ka into, this value is 1, and this is 0.5. So what is Ka here? Ka is 0.5. You can substitute here, Ka into m of t. So m of t is given, Ka we know, which is 0.5 divided by 1 plus t square. Ka into m of t is going to look like this. M of t is given, Ka we found out, just mix both of them. Ka into m of t is 0.5 times 1 by 1 plus t square. A question based on very simple basics. Okay, I hope you have understood. Okay, so this is a question based on simple amplitude modulation only, but not on single tone. Generally we use the formulas based on single tone. Okay, but since message is clearly not a single frequency message or a sinusoidal message, we have to use the general message formulas. Okay, very good, very good, Monica. I'm moving on to the next question. Ready for the next question? Come on, now we have come to frequency modulation. It's an easy question. Just by giving graph and all that, it's looking like maybe a tough question. When you're looking at the question, don't be afraid of the question. Be confident of what you know. Very few questions. There might be very few questions which might be scaring you, but there are many other questions which will not scare you. So you should not get scared for questions which will not scare you. Okay, so we'll respect tough questions. We'll get scared, that's fine, but let us not get scared for easy questions. And out of 65 questions that you write, definitely 50 questions, more than 50 questions should not scare you. Okay, most of the questions will not scare you, so be confident. And after looking one tough question and one question scares you, and for remaining questions also will get scared automatically, so that should not happen. Okay, so keep in mind that very few questions will be tough questions. Only very few questions are worth getting afraid of. Okay, the remaining questions are not worth that much. Very nice, very nice. So signal m of t, whose Fourier transform m of f is shown in the figure, is to be transmitted from one point to another. Message amplitude in time domain, message is having an amplitude of message shape we don't know, but it is having an amplitude from -1 to +1, it seems. If FM is deployed for the transmission, KF is given, frequency sensitivity is given, then bandwidth of modulated signal they're asking. So what is the formula for bandwidth of modulated signal? So it is 2 into del F plus FM, or 2 into del F plus bandwidth of the message. 2 into del F plus FM you can write. FM means for single tone we write it as FM, but for general message instead of FM we can write it as bandwidth of message. 2 times frequency deviation plus 2 times bandwidth of message, and 2 times del F plus what is the bandwidth of the message? It is 20 kilohertz. 20 kilohertz. What is del F? We don't know that, but information is given for del F. Since they are saying FM system, frequency modulation, what is the formula for del F? It is KF into mod m of t max. Correct? I hope you remember this. It's for a general message. It is KF into mod m of t max is the formula. KF into AM is a formula which is valid only for single tone message. This is a formula which is valid for sinusoidal message or single tone message. Okay, don't use this always. If there is no information about message, then you can use single tone formulas. If there is information about a message and if it is sinusoidal, then you can use this formula. If there is information about message and it is not sinusoidal, then you have to go with general formula like this. Very good. So KF is given, which is 70 kilohertz per volt. And what is the maximum magnitude of the message? It is given, no. Message goes from -1 to +1, it seems. If you take the modulus maximum value, it will be 1 volt. Right? So it will be 70 kilohertz is the frequency deviation. You can substitute it here. So bandwidth will be equal to 2 into 70 kilohertz plus 20 kilohertz, which is equal to 180 kilohertz. Very good. It's an easy question, and many of you have answered it perfectly. Okay, very nice. Shall we move on to the next question? I believe every one of you have done this question correctly. It's an easy question. I'm moving on to the next question, 10th question. Frequency modulation. FM modulation. Question is based on FM modulation, maximum frequency deviation of the modulated signal, and the power in the modulated signal they're asking. Del F, maximum frequency deviation is what they're asking. And they're also asking power in the modulated signal, power in the FM modulated signal. These are the two questions they're asking us. They're saying that they're using frequency modulation. Let's see who will answer this. Message is sinusoidal. Is it sinusoidal? No, right? It's not sinusoidal. It is sync function. That's fine. At least second part of the question is very easy. I think I've missed the other options, right? A, B options are there. Option C, option D I should be giving, maybe. Second part of the question is easy, at least. First part of the question, it is little tricky because sync function is involved. It is little tricky, but second part is easy. Power in FM modulated signal is same as carrier power. I think that part of the question should be easy for you. Kishan, very good. I'm not sure what are the answers. I don't remember them. But anyway, we will solve it. Carrier power. Before modulation, carrier amplitude is 50. So power is 50 square by 2R. Since R is not given, we can take it as 1. So it is 1250 watts or 1.25 kilowatts. Right? Option A and option B both are matching with the power part. So we can eliminate option C and D. Sorry, D is also there. See the same answer, 1.25 kilowatt. So we have calculated the second part. Let us calculate the first part. Frequency deviation. How about the frequency deviation? What are the formulas for frequency deviation? Using given data. Modulation index is 6, which is beta. Beta is given. correct? So using beta, what is the formula? Beta times FM, is that okay? It's a single tone formula, but for a general, what we can do, we can write it as, instead of FM, we can write it as bandwidth of message. Bandwidth of message. Beta times bandwidth of message. So what is beta? Beta is 6. And what is the bandwidth of the message? That is what we have to figure out. So M of T, message signal bandwidth, is what we have to figure out. So if you want to figure out the bandwidth, one simple technique is find the Fourier transform. That's it, as simple as that. As simple as that. So message signal M of T is equal to 5 sinc of 400T. So I'll just rewrite it as, sinc function means sine 400 pi T divided by 400 pi T. Okay, so I'll just recollect one Fourier transform. Very simple Fourier transform, easy to remember. This should be always in your mind. Sine AT by pi T. Sinc function in this format, sine AT by pi T format. The Fourier transform is very easy to remember, which is rectangle of omega divided by 2a. Rectangle of omega divided by 2a, which is something like this. It's a rectangle from minus a to plus a as a function of omega. You have to mind this, it is a function of omega with a height of 1 unit. So that is the Fourier transform of sine AT by pi T. Whenever you are given any sinc function of any form, you just try to convert it into this form. Okay, so see this one, it is 5 divided by 400 outside. Can I write it as sine 400 pi T divided by pi T? Is that okay? Now is it in this format? Now it is in this format, right? So what would be the Fourier transform of this one? Fourier transform will be rectangle from minus a to plus a. Rectangle from, for this part, only for this part, the Fourier transform is from minus a to plus a. What is a here? Whatever is inside sine. Whatever is inside sine. What is inside sine? Minus 400 pi. So it is a rectangle from minus 400 pi to plus 400 pi. Right, as a function of f. Right. So what is the height? It's not, height is not required for us, but anyway we can find it. Sine 80 by pi T Fourier transform is rectangle with a height of 1. So 5 by 400 is multiplied. In the Fourier transform also same 5 by 400 will be multiplied. Is that okay? It's not required, but doing it perfectly would help you in solving some other problem. Okay, fine. So what is the bandwidth? The highest frequency in the message. This is the Fourier transform of the message, which we can write it as M of f. Once you find Fourier transform, bandwidth is very simple to find. The maximum frequency in the message, we call it as bandwidth. And how much is the bandwidth? 400 pi radians per second. 400 pi radians per second, because it is in terms of omega. Try to understand this. It is as a function of omega, we have written it minus a to plus a. So as a function of omega, it is minus 400 pi to plus 400 pi. As a function of f, if you write, it is just divided with 2 pi. 400 pi becomes 200 hertz. 400 pi radians per second is same as 200 hertz. So what is the bandwidth of the message? It is 200 hertz. So if you know about sinc function, all this you don't need to do. You could have directly guessed the bandwidth. So I've explained in my special classes, in many of my classes, about sinc function. So this is a tricky function. Whenever sinc function is involved, the problem will take time. That's why you try to master sinc function. You try to master it. Okay, so spend some time on sinc function. On the 3rd, I think, on 3rd of February, on BYJU'S Exam Prep platform, I'm taking a 45 minutes class on the sinc function and its Fourier transform, inverse Fourier transform, all that. If you want, you can attend the class. In many of my other classes also, I used to work on sinc function, because it's a very, very important function. They might give you questions based on sinc function using sampling concept also, using Fourier transform concept also. In multiple concept, if they want to make the problem little tricky, they will take the help of sinc function, because sinc function is little tricky. So to make it easy, what you should do, you have to master sinc function. Try to understand in and out of sinc function. Try to understand its Fourier transform. Try to understand different forms of sinc function, like sometimes sinc function is given as sampling function. Sometimes it is given in this format. There are 3 formats in which sinc function will be written. So sometimes it is written as sinc of 80. Sometimes it is written as sampling of 80. Right? These 3 formats. Try to master these 3 formats. Okay, very good. So if you're already a master of sinc function, then this will be like an easy question. So bandwidth of message, this message bandwidth is 200. So that is what we have written here. It is 1200 hertz is the frequency deviation. So it is 1.2 kilohertz. Option B is the right answer. Very good, Kavya, and very good, Kishan. Wonderful. Very good, Nitin. I think you have remembered what is taught in the classes. Very good. I appreciate it. Shall we move on to the next question? Let's move on to the next question. Let's move on to the next question. Come on. It's an easy question. In the exam, nobody will say whether it is an easy question or tough question, okay? Try to attempt every question in the same manner. Assuming it is an intermediate level question or an easy question, just read the question. Then you'll have at least confidence to attempt the question. Okay, if you assume it as easy to intermediate level question, your assumption is right most of the times. No, out of 65 questions, as I told you, more than 50 questions are easy questions, easy to intermediate level questions. So your assumption will be right most of the times. So it's good to assume the question that you're reading will be easy to intermediate level question. There is nothing wrong in that. You'll be right most of the times. Whenever once you see the question and if you get afraid of the question, then what happens? While reading itself, you will feel like, I don't know this question. Without confidence, we can't solve the questions that we know also. Okay, come on. I think you should have answered it by now. This question should not take much time. It's an FM modulated signal. What behind my head, it is FM. FM. This is FM. Very good. Some of you have answered it already. Very good, Kishan. Very good, Nitin. Wonderful. Keep it up. Come on. I'll wait for half more minute. Message is not sinusoidal. You have to mind that. Message is some kind of periodic square wave form. So they're talking about FM modulated signal. What they have given in the problem, let me do it. Frequency sensitivity is given. Find the maximum and minimum instantaneous frequencies of FM modulated signal. If you know the basics of FM modulated signal, this would be an easy question. If you have blindly remembered the formulas, then it will look like a difficult question. So fine. So what is the formula for instantaneous frequency? Do you remember this? Instantaneous frequency can be written as Fi equal to Fc plus Kf into m of t. I hope you remember this. Instantaneous frequency relation. Instantaneous frequency is changed according to message. Instantaneous frequency relation is like this. Fi equal to, Fi means instantaneous frequency of the modulated signal. FM modulated signal instantaneous frequency is given as Fc plus Kf into m of t. And what is Fc? Fc is 5 megahertz. Carrier frequency is given as 5 megahertz. You can substitute that. Plus Kf is given, which is 50 kilohertz per volt, 50 kilo into message m of t. So Fi is like this. Now what they're asking us to find is, find the maximum and minimum instantaneous frequencies. They're asking us to find Fi max, and they're also asking us to find Fi min. So try to analyze. So Fi max will happen when m of t is max. So it is Fc plus Kf into m of t max. When m of t takes maximum amplitude, we get instantaneous frequency to be maximum. And how much is that? When m of t is maximum, what is the maximum amplitude of m of t? Which is 10. When you substitute the 10 here, we get Fi to be maximum. So in this formula, substitute m of t with 10 to get maximum instantaneous frequency. If you substitute 10 here, it becomes 500 kilohertz. 5 megahertz plus 500 kilohertz. 500 kilohertz means 0.5 megahertz. When you substitute 10 here, this is 500 kilohertz or 0.5 megahertz. 5 megahertz plus 0.5 megahertz is 5.5 megahertz. 5.5 megahertz. Okay. Similarly, when will you get a minimum instantaneous frequency? Fc plus Kf into, the only variable parameter here is m of t. When m of t is taking minimum amplitude, we get minimum Fi. When m of t is taking maximum amplitude, we get maximum Fi. So if you want Fi min, you should take m of t to be minimum. And that happens to be Fc is 5 mega plus kf is 50 kilo into what is the minimum value of the message? It is minus 10. It is minus 10. This is 5 megahertz. This is 0.5 megahertz minus 0.5 megahertz. 5 megahertz minus 0.5 megahertz is 4.5 megahertz. So answer is option A. Very good. Some of you have answered it. Others, I don't know why you are not confident in this question. Maybe if you have not known this part, learn this part. Very, very important. Okay, shall we move on to the next question? When required, I'll revise some concepts also. Whenever a question demands some revision, little bit of revision, I'll do the revision also. I'm moving on to the next question, 12th question. Let's see how many of you will answer the right answer it correctly, and how many of you will answer it in shortest amount of time. This is a very, very good question. No silly mistakes. Make sure that there is no silly mistakes. Yes, in FM modulation only, these type of questions are being asked in the last few years. Yes. Come on. Try it confidently. Be careful, no silly mistakes. Apply whatever concepts you know carefully. If we don't solve the question without knowing the concept, that's fine. We will not feel bad. But if we know the concept and we are able to solve the question, but we got wrong answer because of a silly mistake, that feels very bad. Correct? You might have felt that a lot of times, right? In mock tests, other tests also. We feel irritated. We feel like we feel very bad after the exam, right? If we had not answered a question that we are not well aware of, we don't know the concept of, we will not feel bad at all. It is 500 by pi. Yeah? Very nice. Very good. Issue Deepak. Many of you are answering the same thing. Maybe it should be B. I don't know. I'll solve it and I'll tell you. Okay. So should I revise a little bit? Can you give me a few minutes to revise? I'll just recollect the concepts once. For people who are not aware of this concept, I'll just revise it quickly. FM modulated signal. What is the general equation? Let me write it. AC into cos of omega CT plus 2 pi kf integration of m of t dt. This is the general formula, general equation of FM modulated signal for any message. If you have remembered it as cos of omega CT plus beta sin omega mt, that is valid only for single tone case, sinusoidal message. But here message is clearly given that it is not sinusoidal, it is some other signal. So that's why whenever message is given as other than sinusoidal signal, we have to use the general equation, general formulas, not single tone formulas. Okay. If you have remembered only single tone formulas, then it will be difficult to solve this question. You will not be able to solve this question. You have to go with general formulas. Okay. So now, what is the angle here? What is the angle here? Angle is whatever is inside cos, that is the angle, no? Omega CT plus 2 pi kf integration of m of t dt. Right? I'm revising little bit. Try to understand carefully. Now, what is the relation between, this is the most important point in frequency modulation and phase modulation. What is instantaneous frequency and angle relation? Whenever you know angle, whatever is inside cos, that is the angle. For PM also you can apply the same formula. The relation between angle and frequency is 1 by 2 pi times d by dt of theta of t. Differentiation of the angle. You do differentiation of the angle and divide it with 2 pi, you get the instantaneous frequency relation. The same relation is valid for any scheme, any modulation. For any modulation, relation between angle and frequency is this is the relation. Okay. Since they're talking about frequency deviation, whenever they ask us about frequency deviation, try to get instantaneous frequency, because instantaneous frequency talks about frequency. So if you know Fi, from Fi it's easy to find frequency deviation. So whenever somebody asks you frequency deviation in a tough question, tricky question, try to find Fi. And in this question, it is clearly given, theta of t is given. Using theta of t, can we find Fi? Could you tell me what is Fi here? 1 by 2 pi into d by dt of, I'm talking about general thing only even now. I'll get into the problem little bit later after a few minutes. So I'm just trying to revise for the sake of a few people who are not aware of this concept or few people who have forgot this. Observe carefully. So omega ct, differentiation is omega c. If you divide it with 2 pi, it becomes fc plus 2 pi cancel here. It becomes kf into integration and differentiation gone. It will become m of t. This is the basic relation that is valid in frequency modulation. But the point I want to make is, if you know modulated signal equation, angle modulated signal equation, whether it is FM or PM, if you know the angle, differentiate it and divide it with 2 pi, you'll get instantaneous frequency. Once you know instantaneous frequency, you can find maximum frequency deviation. It's very easy. Right. So could you tell me what is maximum frequency deviation here? Maximum frequency deviation is the maximum value possible here. The base frequency is Fc. As m of t goes from 0 to positive value, 0 to negative value, frequency also deviates from Fc. From Fc, it goes above or below Fc. So frequency is deviating from Fc because of m of t. Whenever message amplitude changes, instantaneous frequency also deviates from Fc. So what is the maximum deviation? Maximum deviation happens when this becomes maximum. So when this becomes maximum deviation, when this becomes maximum, take the modulus of m of t maximum. M of t is the only changing signal. When m of t takes maximum magnitude, that is when we get maximum deviation from Fc. Okay. And can anyone tell me what is the maximum phase deviation? Maximum phase deviation. Anyone can tell me maximum phase deviation, which is also same as beta. Beta and maximum phase deviation both are same. Beta and maximum phase deviation both are same in FM and PM both, always. And how much is that? If you want maximum phase deviation, look at the angle. Look at the angle. Basic angle is omega ct, and because of m of t, the angle part changes. No, basic angle is omega ct, and the phase part. This is the phase part. Phase part of the signal is controlled by m of t. As m of t changes, as integration of m of t changes, phase part also goes positive or negative. Okay, so integration of m of t decides the maximum phase deviation possible. Basic phase is when m of t, if you don't apply message, this part becomes 0. So basic phase is 0. Because of m of t, what happens? Phase is deviating from 0 to positive phase or negative phase because of m of t. When there is no m of t, what happens? This part becomes 0. 0 phase is the basic phase. From 0 phase, it is deviating to positive phase or negative phase. So when this has a maximum magnitude, that is when we get maximum phase deviation. And how much is that? It's 2 pi kf modulus of integration of m of t dt modulus maximum. This is the basic. Okay, see this one? This is the most important relation. In FM and PM, any tough question, any trick question, this you can take the help of this relation. Okay, wonderful. Now I have just done some small revision here, so I hope it has helped you a little bit. Fine. Now let us come back to the question. So this is the angle here. Now message is given. Peak frequency deviation of the above FM signal is. Peak frequency deviation they're asking us to find. Peak frequency deviation. Kf is not given. Kf is not given. But if you want, you can match with this. What is in this here? 100 is given here. In place of 100, what do we have? You can match it with 2 pi kf. Yes, you can match it with 2 pi kf. Or directly you can go with the concept. No. Directly you can go with the concept, right? Directly you can go with the concept. You can match it as 2 pi kf is equal to 100. You can do that. And which means kf is equal to 100 divided by 2 pi. You can do that. So kf unit is kilohertz per volt. Hertz per volt, right? Yeah. Hertz per volt is the unit. Okay. Wonderful. Kf we know. Now could you tell me what is del f? Maximum frequency deviation. Del f max is equal to kf into mod m of t max, which is equal to 100 divided by 2 pi into what is the maximum amplitude of the message? It is 10 volts, which is equal to 1000 divided by 2 pi, which is 500 divided by pi hertz. That is the maximum frequency deviation. Because we are matching this with this one, we are able to get KFE quickly, and we know the formula for frequency deviation. That is how we are able to find it. Other way, what is the other way? Let's say if you are confused with the formulas, so if you're not sure about your comparison and all that, so then you can go with the basics. No, what is the angle here? Angle is 2 pi fc into t plus 100 times. You can go with the basics, minus infinity to t. You can go with this basic that I've told you, m of lambda d lambda. The variable here, whether it is lambda or t or whatever variable, it doesn't matter. Okay, right. So since theta of t we know, what do we want to find? Frequency deviation. Whenever you want frequency deviation, you should know instantaneous frequency, because you see this one, how did we get this? We got this from instantaneous frequency, right? So can we find instantaneous frequency? Yes, we can find it. 1 by 2 pi into d by dt of theta of t. We can use this formula. So if you apply that formula, it becomes fc plus 100 divided by 2 pi. Because we are dividing with 2 pi, it's 2 pi. Because of differentiation, this integration will go off and it becomes m of t. Okay, because finally upper limit is t, so we have to substitute that here. So that's why it will become a function of t. Now we got this. So we want maximum frequency deviation. Just go with the basics. Basic frequency is fc, and from fc, frequency is deviating because of m of t. Frequency is deviating because of m of t, and when m of t has maximum magnitude, that is when we get maximum deviation. Maximum deviation happens when m of t takes maximum magnitude. And how much is that? It is 10. You can substitute that, which is the same answer. If you're not comfortable with the comparison and all that, you can go with the general basics. Take the angle, differentiate and divide it with 2 pi, you'll get instantaneous frequency. From instantaneous frequency, always you can get maximum frequency deviation. From angle, you'll have the phase part. From the phase part, you can get maximum phase deviation or modulation index. Okay, this concept will help you in solving the next problems that are coming up. So many problems were framed on this basic. So remember this basic. Last 4-5 years, whatever questions were asked in FM and PM modulation were based on the simple funda, whatever I've discussed in this slide. Okay, so I'm moving on to the next question. Let's see how many of you will solve it. Come on, make it quick. This is an easy question. This is an easy question. Just like that, you can solve it. It is single tone modulation also. You can observe that. Message is sinusoidal here. You can observe that. So you can apply single tone formulas, which are very easy formulas. So they're asking us to find peak phase deviation, which is same as beta. This is what they're asking us to find. They're also asking us to find maximum phase frequency deviation. Anyone can answer? It's a less than 1 minute question. Easily answerable. No silly mistakes here. Simple calculation. Right. So if you take a general angle, this is angle modulated. Okay, for angle modulated signals, general formulas are same. Okay, AC cos of omega CT. For a single tone case, it looks like this: beta sine omega MT. Angle modulated means it can be FM or it can be PM. But for FM and PM, both have similar formulas. If you remember, we can use the common formulas that are there for FM and PM. So what is the formula that we have for beta? Beta is same as maximum phase deviation. This is the phase part. In the phase part, whatever is the maximum value possible, that is the maximum phase deviation, which is also same as beta. What is the maximum phase deviation possible? When message is not there, phase is 0. When message is there, when sign takes +1, we get 3 radians as the maximum phase. Original phase. When no message, 0 phase. When message takes +1 or -1, the phase is deviating from 0 to 3 or -3. What is the maximum deviation here? 3 radians. So phase deviation is 3 radians. Phase deviation is same as beta. Very simple. In any angle modulated signal, FM or PM signal, just observe the phase part. Whatever is the maximum possible value in the phase part, that itself is the phase deviation or beta. Very good. So 3 radians. I think we can eliminate the options. There is no need to solve the second question also in the exam. 3 radians, only one option is there with 3 radians. Phase deviation is 3 radians. There is only one option, so you can go with option. You don't need to solve the second part of the question. But anyway, we will solve it. So what is the formula for del F? Kf into mod m of t max or Kf into am. That can we use that formula? We can't use that formula because we don't know whether it is FM or PM. When they're saying angle modulated signal, we have to use a formula which is same for both FM and PM. So what is the formula? Can we write as beta times FM? This is a formula which is common for both FM and PM. We can use this formula. We should not use Kf into mod m of t max or Kf into am. Kf into am we can't use because we don't know if it is FM or PM, right? So beta into FM is a formula which we use for frequency deviation both in FM and PM, which is equal to beta is 3, just now we found it, into what is the message frequency? 10 to the power of 3 is the frequency in the message, which is 3 kilohertz is the maximum frequency deviation. So option A matches. Very good question, very good Deepak, very good Nasreen, wonderful. Shall I move on to the next question? 13 questions are over. You can match how many questions you answered correctly without any silly mistakes. That will tell you how much careful you should be in the exam, in what areas you should be careful, what areas you are strong, what areas you have to work a little bit more, what areas you should revise. You'll know that. I'm moving into the next question, 14th question. So in this question, we're talking about phase modulated signal. Just apply your basics properly. Periodic triangular waveform, it seems. Just imagine the message signal first. Read the question. Understand what is given. Understand what is given. So they're saying PM, no? First, recollect what you know about PM. What is the general equation of PM signal? Since message is not sinusoidal, you have to go with the basics. You have to go with the very basics. PM signal equation is AC cos of. If you know how to do the question, you just go ahead and do it. This is the general equation of PM modulated signal. So they are talking about instantaneous frequency. How do we get instantaneous frequency? We know the angle, and we can get the instantaneous frequency using the relation between angle and instantaneous frequency. I'm just recollecting what we know. I'm recollecting what we should be using here, which is Fc plus Kp divided by 2 pi into d by dt of m of t. If you know PM signal equation, from the equation we know the angle. From the angle we can find instantaneous frequency, because the question is all about instantaneous frequency only. Okay, right, wonderful. Anybody has answered it already? Anyone? I did not do the question. I have just recollected few things about PM which you should be using. Anybody can answer me? Seshu, very good, very quick. Very nice. I think that should be correct only. Oh, multiple people have given multiple answers. Check your answers. Whenever there is a doubt, just cross check your calculations. Cross check if you are missing something. The maximum and minimum values of instantaneous frequency, it seems. Fi max we want, Fi min we want. Fi becomes maximum. Fi is controlled by d by dt of m of t. Fi is controlled by d by dt of m of t, and when d by dt of m of t becomes maximum, when d by dt of m of t becomes maximum, when this becomes maximum, we get Fi max, and Fi min we get when d by dt of m of t becomes minimum. Then this becomes minimum. Okay, so information about m of t is given, no? So we don't need to plot the signal, but they said that it is triangular waveform, periodic triangular waveform with a maximum amplitude of 1, it seems, and minimum amplitude is minus 1, it seems. Okay, and it's a very good question, man. Yeah, so triangle wave with periodicity is 10 power minus 3 seconds, it seems. Periodicity is 10 power minus 3, it seems. So which means from here to here, it is 10 power minus 3, which is 1 millisecond. 1 millisecond as a function of time. This is 1 millisecond. So d by dt of m of t max means its maximum slope. Okay, d by dt of m of t min means its minimum slope. So what is the slope? Can anyone tell me what is the slope here? If this total thing is 1 millisecond, this value, what is this length? 0.5 millisecond. I hope you have understood that part. You have to make use of this also. That is a tricky part in this question. So the period is 1 millisecond, means the half of the period is 0.5 millisecond. Now see this one. The signal is going from 1 to minus 1 within a duration of 0.5 millisecond. So what is the slope here? Slope is equal to, you can write it as y2 minus y1 divided by x2 minus x1 also, that is also fine. So y2 minus y1 is minus 1 minus of 1, y2 is minus 1, y1 is 1 divided by duration is 0.5 millisecond minus 0 is 0.5 millisecond, which is 0.5 into 10 to the power of minus 3, which is equal to minus 1 is minus 2, and 0.5 goes to the numerator, it becomes minus 4 into 10 to the power of minus 3. Okay, that is the slope here, because the slope is negative here. And what is the slope? Positive slope here, same thing, no? Same magnitude, which is slope is 4 into 10 to the power of minus 3. I hope you understood this part. Is that okay? Finding the slopes, we have to use the slopes here because we want differentiation of the message. We want maximum slope of the message. Differentiation means slope. We want maximum slope of the message, minimum slope of the message. And we know FC is 100 kilohertz. I'm just substituting the values here. Only trick in the problem is you have to find the slopes. And many of you will be messing up with the 10 power minus 3 part. So this is 1 millisecond. You'll say that the slope is minus 2 are here and plus 2 here. That is not true, because this is not like the width is not 0.5 here. It is 0.5 millisecond. Some of you might have done small mistake here. You would not have taken this 10 power minus 3 into consideration. If that is not taken, then we will get a wrong answer. Be careful with that part. So Kp is 100 kilohertz given, divided by 2 pi into, what is the slope of the message? My mistake, one second. Kp is 2 pi, right? Kp is 2 pi. Kp is given as 2 pi. I'm substituting that here. What is the maximum slope of the message? 4 into 10 to the power of minus 3. Sorry, my mistake. It should be 10 power plus 3, no? 10 power plus 3, my mistake. So it is minus 1 divided by 0.5 into 10 power minus 3. If it goes to the numerator, it becomes minus 4 into 10 power plus 3. And the positive slope here is 4 into 10 power plus 3. So I have done a small calculation mistake. How did I understand that I have done a mistake? Because this value will be very small compared to this. Then I got it out what mistake I have done. Sometimes you can identify your mistakes in that way also. Right. So this is 4 kilohertz. It is 104 kilohertz, correct? And how much is this one? 100 kilohertz is Fc plus Kp is 2 pi divided by 2 pi. And what is the minimum slope of the message? It is minus 4 into 10 to the power of 3, which is 96 kilohertz. So answer is Actually, okay, 96 kilohertz and 104 kilohertz. That is the right answer. Actually, they're asking maximum and minimum. Actually, maximum first and minimum second should be there, but the only best option that is matching is the fourth option. But anyway, they did not say respectively, but maximum minimum values of instantaneous frequency for a phase modulated signal respectively they did not say, which means the order is not important. So the only answer that is matching is option D. So I hope everyone agrees with me on this. Seshu, Nasreen, Deepak, have you corrected your mistake? Now is your answers match? Are your answers matching with mine? Can I go ahead? If you've done a mistake, try to do it once again. Try to understand this again. So this part, the concept is very important and finding the slope also is very important. Last few years, this kind of questions were asked in the previous papers. You have to be careful. So there is a chance to make silly mistakes while finding the slopes here. Fine. Can I go ahead with the next one? '15th. Come on. It looks scary, but don't get scared. You should be able to do it. Given your basics are right, you should be able to do it easily. Nasreen, you want me to explain the graph? Sure, definitely I'll explain. Just wait for a minute so that others can copy the question. Then I'll go back to the previous question and I'll explain you. Understand the question carefully. Understand what each blocks will do. When you pass a signal through frequency multiplier, when you pass an FM signal through a frequency multiplier, the resultant signal equation will change, shape will change, everything will change, but still it will be also be an FM signal. I'm just recollecting some basics here. If modulation index is beta here, what will happen to the new beta value? If the frequency multiplier has a factor of n, new beta will become n times beta. If the frequency deviation is del f here, it becomes n times del f here. And if the carrier frequency is fc, it becomes n times fc. If the message frequency is fm, it will not change. The only thing that will not change is message frequency. So this is the basic that you need to apply here. Okay, so let's wait for people to answer. I hope you have copied the question. I'm waiting for your answers now. So I'll wait for a minute or two. In that 1 or 2 minutes, I'll go back to the previous slide and explain a little bit about the previous question for some of you who have not understood. The graph, since it is periodic triangular waveform, this periodic triangular waveform. So you know how a triangular waveform looks like, right? So triangular waveform looks like this. So they're saying periodic triangular waveform with 10 power minus 3 seconds means they're saying the period of the signal. Period of the signal is 10 power minus. Since the period is 1 millisecond, so from here to here, one cycle is completed and the next cycle starts. So time taken for one cycle is 1 millisecond. So this length is, if this total thing is 1 millisecond, this part will be 0.5 millisecond. So the amplitude has changed by 2 volts, minus 2 volts. It has changed by minus 2 volts in 0.5 milliseconds. Okay, and how much will the amplitude change in 1 second? How much the amplitude changes in 1 second, that is what we call a slope. Minus 2 divided by 0.5 milli, which is equal to minus 4 into 10 to the power of 3. That is how we find the slope. You can find the slope in any manner that you know. Okay, I hope that clears, Nasreen. If you are not clear, you can let me know what exactly you want me to explain in the graph. Since they said periodic triangle waveform, I have just plotted a triangle waveform. Since the periodicity is given, according to that I have written 1 millisecond here. Okay, so if there is any question, you can ask me. So I'll move to the next question here. So I hope many of you have answered it. I think your answers are correct. So narrowband FM signal. So this is narrowband FM modulator. Message is given. So what we get here is narrowband FM modulated signal. S of T NBFM. S of T means modulated signal. NBFM subscript means narrowband FM modulated signal. Okay. So now that narrowband FM signal has a F1 means what can be F1? We don't have any notation called F1. Okay. What is the only frequency that will be there in FM signal or any modulated signal? Carrier frequency only, no? So don't worry about the notation. So what they might have meant with F1 is carrier frequency, okay, or some frequency, whatever frequency it is, because they have used FC notation here. I think that's why they have changed the notation here. Okay, that's fine. Let's take it as F1 only. So the frequency of the carrier in this is 200 kilo and frequency deviation is 225 kilohertz. Now this is frequency multiplier. No, for frequency multiplier, what happens to carrier frequency? Let me say F2 here. What happens to frequency of the carrier? It becomes beta times carrier frequency. Carrier frequency changes by n times when you pass through frequency multiplier. So it is F2 times F1. So beta is 64. It becomes 64 times 200 kilo hertz. And how about the frequency deviation? Frequency deviation del F2. Let me say it is del F2 here. It is beta times del F1, which is equal to 64 times 25 hertz. Next, what is it here? Here carrier frequency. What is the frequency here? Since we are passing through frequency multiplier, it becomes 48 times frequency at the input. What is the frequency at the input? It is F2. It becomes 48 times frequency at the input, which is 48 times F2 is 64 times 200 kilo. And what is del F here? Del F is, since we are passing through frequency multiplier, del F changes by 48 times or beta times. It is 48 times del F2, which is equal to 48 times. What is del F2? We know it already. Del F2 is 64 into 25 hertz. So you can calculate, you can use the calculator and let me know. So 48 into 64 into 200 kilo, I think it should be 614 megahertz. And del F is 676.8 kilohertz. Is that okay? I think many of you have answered it perfectly. Very nice. Option D is the right answer. Very nice. Good question. This is a very good question. Not a very tricky question, but the graphs and all that, it will scare us a little bit initially when we look at the question, but it is not so scary. Most of the questions are not scary. Only thing is they scare us by the look of it. I'm moving on to the next question, 16th one. Come on, let's see how many of you will solve it. Similar question, but I have changed a few things. Come on, do it quickly. Let me know the answer. I'm expecting you to do it within 2 minutes. If you're good enough, you can do it within 2 minutes. Come on. No mistakes. No silly mistakes. Go stage by stage. At what stage? At every stage, what is happening? At every stage, what is happening? Try to understand that. Analyze what is happening here. Finally, they're talking about frequency, FC and del F here. Frequency deviation and carrier frequency. That is what they're interested in. So at every stage, try to analyze them. At this stage, what is F2? F2 is beta times F1, which we have done it already, which is 64 times 200 kilohertz. And what is del F? Del F equal to beta times del F. This is, let me say, this is del F2 here. Beta times del F1, which is 64 times 25 hertz. Okay. Now they are doing this is a multiplier. Okay, this is a multiplier. For this multiplier, two inputs are given. One input is the FM signal here, and another input is local oscillator signal. This is just a multiplier. Okay, what happens when you multiply, when you pass it through multiplier? That phase, this stage is new for us, right, in this problem. So that only that stage I'll just analyze. At this place, what we have is FM signal. Okay, at this stage we are having FM signal. S of t, FM signal is equal to AC cos of, what is the carrier frequency here? It is F2 here. It is F2 here at this stage. Cos of omega 2t plus cos of omega 2t. Let us assume sinusoidal. Is that okay? I think we can assume sinusoidal. Beta times sin omega mt. Is it okay? Beta 2, let me say, because the beta here, let me call it as beta 2. Now if you pass it through a frequency multiplier, let me say it is cos omega 3 into t. Let me call it as f3 or FLO, right? Is it okay? It is okay. Let me take the same notation over here. I'm just trying to explain what is happening exactly there. If you're aware of it, you can do it easily. So cos omega LO, local oscillator frequency, into t. Now what is happening at the output of multiplier? I just want you to let you know that. So when you multiply these two things, this part with this part, cos A into cos B, it's like cos A into cos B, which is like cos of A plus B plus cos of A minus B. This is like cos of AC. Cos A into cos B is cos of A plus B plus cos of A minus B, which is AC into cos of A plus B is cos of omega 2 plus omega LO into t plus beta 2 times sin omega mt plus AC times cos of A plus B I have written here. Now it is cos of A minus B. It is cos of omega 2 minus omega LO into t plus beta 2 times sin omega m into t. The point I want to make here is, what is this multiplier doing? Multiplier means when you do multiplication of two signals, it's like cos A into cos B. We will have two terms, which is cos of A plus B plus cos of A minus B. So because of this one, these two terms, did the modulation index change? Modulation index did not change. No, because of multiplier, modulation index will not change. If modulation index does not change, frequency deviation also does not change. Mind this, multiplier does not change frequency deviation. I hope you understood that part. So here at this stage, what is the frequency deviation? Del f3, let me call it. Frequency deviation does not change. So it will be 64 into 25 only. It will not change. And what will be f3 here? F3 means the frequency present here. You will feel that, sir, there are two signals, which means there are two frequencies possible. There are two frequencies possible. So the two frequencies possible are f3 can be f2 plus FLO or f2 minus FLO. Both of them are possible because multiplier output can be any of these two signals or both the signals also. But generally when we use a multiplier, at the multiplier output, we should have both of them. But whenever we are using a multiplier, at the output of multiplier, we'll use a band pass filter so that one of these two will be eliminated. We don't want two terms. We don't want this frequency and this frequency, both of them. We don't want both the terms. We want only one term. Whenever a multiplier is used, generally band pass filter will be used. That is not shown here. Band pass filter is not shown here, but they said difference. They said difference, which means only the difference term is used. In this case, they are using this. So what is F3? Since they have said difference here, they are using this. They are using this. If they had not said difference, then we would have been confused with both of them. Okay. Since they said difference, we can go with F2 minus FLO. Okay. So what is F3 now? Can you tell me? F2 minus FLO, because they said that is difference here, and we know what is F2. F2 is what? 64 into 200 kilo hertz minus local oscillator frequency is given as 10.8 megahertz. 10.8 megahertz. So what is F3? 64 into 2 is 12800 kilohertz, which is 12.8 megahertz minus 10.8 megahertz. How much is that? It is 2 megahertz. I hope you also got the same answer for F3, but we don't want F3 here. We want FC. So what is F3? F3 we got it as 2 megahertz. So we know the frequency of the signal here. This is the signal that we have here. This is the signal at this stage. Only this part is available here. So that signal has a carrier frequency of 2 megahertz and frequency deviation of 64 into 25. Now, what happens after passing through frequency multiplier? After passing through frequency multiplier, we get FC. So what is FC is equal to carrier frequency increases by beta times. So what is beta here? Sorry, not beta, n times. N times. My mistake, I have used beta here. My mistake here. It is n times F1. It is n times delta F. Okay. I should not use beta here because F2 is n times F1. N is the notation that we take for frequency multiplier, not beta. Okay. Beta is the notation that we use for modulation index. So it is n times F1, n times delta F. Okay. Right. FC is how much? FC is, how do we get FC? Since we are passing through frequency multiplier, F3 increases by 48 times and it becomes FC. 48 times F3, which is equal to 48 times F3 is 2 megahertz. We just now found it, which is equal to 96 megahertz. There are two options matching with this, so we have to solve the next one also. What is del F finally? Del F, frequency deviation increases by 48 times. The frequency deviation at this stage, F3 stage, the frequency deviation is 64 into 25. It is 48 times frequency deviation will increase. So 48 times del F3 is 64 into 25. So you can calculate this, and how much is that? I think it should be 76.8 kilohertz. Wonderful. Option A. Very good, Kishan. Very nice. Very nice. This is not a very simple question. This is little tricky. You should have the confidence to do it. It's not like a question which you can't solve it. So you can, you know what a multiplier does, what a frequency multiplier does. Only thing is you should have the confidence to apply things that you know. Come on, what happened, Deepak? What happened, Nasreem, Sheshu? I was expecting you to answer this question. Fine, anyway. Don't worry. If you're not able to solve one or two questions, that's fine. Don't worry. You're able to solve other questions, right? It's okay. There is no need to worry. But have the confidence and apply it. If you have confidence, definitely you will be able to solve it. While reading the question, we should have the confidence that I know most of the things. Maybe we might not know everything, but we know most of the things sufficient to solve the questions, right? Okay then. Akhil, we have, okay. The concept, even though concepts are clear, we feel that the concepts are clear. Okay, you might be clear, you might be having more clarity than others, but without solving questions, your clarity will not be perfect. Okay, while solving the questions, you'll be applying the concept, then you'll have a much more clarity. Okay, so solving questions is very, very important. Why we choose minus value only? Nasrin, that's a good question. That's what I've explained. No, see, these are the two options. We can take any of them, but they themselves said no in the question. They said DIFF, difference. Okay, so we also call it as down converter. Whenever they use multiplier, they say down converter and up converter. Down converter means they are saying that they are taking the difference. Up converter means they are taking the some addition. Okay, so if they don't give anything, you can take the difference. You can assume down converter. Okay, very good. Okay, Akhil. Fine, shall I move on to the next question? Very nice. Come on, this is one tricky question. So 17 and 18. So there are two questions here based on similar model. Oh, okay. Similar model. I want to explain this. Okay. So first, let me give you 2 minutes to solve this. Let's see if anybody can solve this. I want to explain a general procedure for these kind of models. Once I explain any kind of model like this, you should be able to solve it very quickly. Anybody can tell me the answer for this? Bandwidth of the modulated signal. What is the formula for bandwidth? What is the formula for bandwidth of angle modulated signal? It's 2 into del f plus fm. We can write, or b we can write for general signal, or you can also write as 2 into beta plus 1 into fm. Instead of fm we can write as b. B means bandwidth of message. Anyone can answer me this question? This is not an easy question, definitely. This is not an easy question. So this is the message part. This is the message part. What are the frequencies in the message? What are the frequencies in the message? There are two frequencies in the message. 1 kilohertz is there and 2 kilohertz is there. What is the highest frequency in the message? It is 2 kilohertz. Bandwidth of the message we know. That much we are clear. Once we know the bandwidth, what else we need to know? Frequency deviation if you know, or beta if you know, then we can solve the question. Bandwidth. Bandwidth can be solved only if you know del f or beta. Which one can we find easily? Saurav, you are saying something root of 125. Why did you get that much complicated answer? Oh, root of 10 square plus 5 square you have done, huh? Okay, fine. Akhil, so there is my Telegram group. You can search by Electronics by Dinesh Gutha, sir. Channel name is Electronics by Dinesh Gutha. You can search with that. You will get my group, and from that you can access my personal Telegram ID also. You can ask me if you want anything on that. Okay. Anybody has solved it? This is little tricky, definitely. You have to apply your basics properly. This is a question which is based on your very basics, the core concept. Should I explain or should I wait? $48.72 Kishan. Okay, so these questions are little means there are many there are many other institutes have given some solutions which are little confusing. So let me clear on this. Let me be clear on this. So whatever procedure I'm going to tell you here, just follow that. Okay, without any confusion, you can solve the questions on this model, based on this model. See the next one also similar model. Okay, next one also similar model, but I have given both causes. Okay, here previous one both sign. Try to understand carefully. Both signs, both costs. Okay. Or one more model is also possible. Okay, one more model is also possible, which is both one cos, one sine, with both having same frequency. That is a different model. I think many of you have solved using that. Okay, so I'll give you that question also. First, let me explain this model. Okay, understand carefully. One more model that is possible is AC cos of omega ct plus beta 1 times cos omega 1t plus beta 2 times sine omega 1t. See this one? Frequencies are same. Okay, frequencies are same here. In that case, you just need to apply some basic here. Any signal of this form, cos and sine together with same frequencies, you can write it as a cos plus b sine. You can write it as root of a square plus b square, into cos of omega 1t plus some phase. Is that okay? Because sine and cos are having same frequency, right? Cos and sine with same frequency, we can add both of them and together we can write it as cos of some signal with some phase. I hope many of you are aware of this part. Whenever you see cos and sine signals with same frequency, you can combine it and write it in this format. If you are able to write it in this format, what is the advantage? The advantage is you can figure out the maximum magnitude possible here. If you can figure out the maximum magnitude possible here, you can figure out the maximum phase deviation or modulation index you can find. in this kind of model. Both one cos, one sine with same frequency. That is one model. I did not discuss this model because this model you'll know how to answer it. That's why I did not give any question based on this model, because it's an easy model. The model that I've given is both cos or both sine. Both sine. Try to understand. Here, these two we can't combine and write it as a single signal, because these two signals are having different frequencies. So you can't combine them and write it as a single signal. That's not possible. So what should we do? Let's go with the basics. Let's go with the basics. Now focus. Try to understand carefully. This is a little tricky. You have to focus carefully. So you want to understand the bandwidth. If you want to understand the bandwidth, you should know the frequency deviation. If you want to understand the frequency deviation, what should you get? Can I say that we should get instantaneous frequency? Is that okay? If you want a frequency deviation, you should get instantaneous frequency, which is 1 by 2 pi times d by dt of theta of t. If you want frequency deviation, you should get instantaneous frequency. But if you can get beta or maximum phase deviation, that is also fine, no? So just try to understand if we can get beta easily. Beta is same as maximum phase deviation. And how do we get that? From the angle itself. In the angle, what is the maximum phase part? What is the maximum phase part? Maximum possible value of, maximum magnitude of modulus of 10 sine 4000 pi t. Our target is to find the maximum value here. 5 sine 2000 pi t. So this is a signal which is difficult to plot, very difficult to plot. Using MATLAB kind of softwares only we can plot them. Manually we can't plot them. Okay. What we want is, if you can figure out the maximum magnitude of this, that is done. We can find the beta. But is it easy to figure out the maximum magnitude of this one? Because these two are having different frequencies. So we don't know if both of them will become, because when it becomes 10, when this sign becomes 1, this sign need not become 1. Correct? If you want to find maximum, that happens when both signs becomes 1 or one of them becomes 1. We don't know if both of them are becoming 1 at the same time. We don't know that, because this is complicated shape. Okay. At t equal to 0, both are becoming 0. At t equal to 0, both are becoming 0. So we want maximum magnitude. Okay. So is it easy to understand the maximum magnitude here when both are sines? No. When both are sine, it is difficult to figure out the maximum magnitude. Is that okay? I hope you're understanding. But when both are cos, see this one? The angle here is, try to understand carefully. The angle that I have given is 8 cos 2000 pi t plus 6 cos 1000 pi t. Here the phase band, this is the phase band, okay? So if you want maximum phase deviation or modulation index beta, what you need to figure out is, you need to figure out the maximum magnitude possible here. 8 cos 2000 pi t plus 6 cos 1000 pi t. Understand carefully. Focus carefully. Could you figure out the maximum magnitude for this one? This total signal. Can you figure out the maximum magnitude here? For this one, it is easy to figure out. Can you put t equal to 0? If you put t equal to 0, at time t equal to 0, previously, we don't know at what time both will become maximum. It's difficult to figure out. Because at t equal to 0, both are becoming 0. It is not maximum. At other times, it's difficult to figure out. But for both causes, it's easy to figure out. If you put t equal to 0, this cos becomes 1 and this cos also becomes 1. Both causes becomes 1. And that is when we get the maximum value possible. And that is how much? 8 plus 6 is the maximum magnitude possible, which happens at t equal to 0. If both are causes, we can put t equal to 0 and we can write it as just 8 plus 6, which is 14. Here also, both causes also, we can't write it as a single cos signal because the frequencies are different. Okay, when frequencies are different, you can't combine it and write it as a single signal like this. Finally, our idea is to find the maximum magnitude possible in the phase part. If you can figure that out, you can figure out the modulation index. Once you figure out the modulation index, you can find frequency deviation, you can find bandwidth, everything we can find. Okay, I hope you're following. So the answer in this case is 14. Let us go to the previous question. Here both are sines. It is difficult to figure out this one. So beta we are not able to figure out. Okay, beta we are not able to figure out. It's not easy. But if you differentiate sine, it will become cos, no? then I think it will become easy to figure out. Beta becomes difficult to figure out, but Fi might become easy, no? Because we are differentiating. So it is 1 by 2 pi times d by dt of 10 sine 4000 pi t. Understand carefully. Any questions you have, any doubts you have, just stop me there itself. You have to observe very carefully. So Fi is equal to Fc plus, okay, Fc plus Fc plus 1 by 2 pi into d by dt of, one second, my mistake, Fc plus, Fi is Fc plus 1 by 2 pi into d by dt of theta of t. Okay, I missed this Fc part here previously. Okay, Fc plus, so if you differentiate this one and divide it with 2 pi, it becomes 10 into sine differentiation will become cos 4000 pi t into 4000 pi plus 5 sine becomes cos 2000 pi t into 2000 pi. This whole thing we have differentiated, and after that 1 by 2 pi should be there, no? So Fc, what is Fc? That is not really important for us, that is not given also. So this 2 pi if you cancel, this 2 pi if you cancel, 2 pi cancel, it becomes 2000. 2000 into 10 is 20,000. 20,000 into cos 4000 pi t plus this 2 pi gets cancelled here, it becomes 1000, it becomes 5000 into cos 2000 pi t. So Fi we got it. So from Fi, can we figure out the maximum frequency deviation here? The maximum value possible here, the maximum magnitude possible here, 20,000 into cos 4000 pi t plus 5000 cos 2000 pi t. The maximum magnitude if you can figure out, I think it is easy to figure out when they both are causes. Maximum magnitude is easy when both are cos. If you can put t equal to 0, at time t equal to 0, both causes will become 1 and it becomes maximum. The maximum value possible here is 20,000 plus 5,000. So in this problem, it's easy to figure out the maximum frequency deviation, but it is not easy to figure out the beta value. When it is difficult to figure out the beta value, just look at here. By looking at the maximal, if you can figure out the maximum value possible in the phase part, you can figure out the beta value. When both are cos, here it is easy to figure out. If both are sine, you can't figure out beta value easily. You have to go to frequency deviation, which can be figured out easily because one differentiation is happening here. So 25,000 or 25 kilohertz is the maximum frequency deviation. So can you tell me the bandwidth now? It is 2 into del f is 25 kilohertz plus b is 2 kilohertz, which is 54 kilohertz. Very good. Some of you have answered it correctly. Wonderful. Very good, Nikhil. Very good, Kishan. Okay, don't apply some formula blindly. Okay, so that formula, you have applied the formula of root of a square plus b square kind of formula, which is valid only for this kind of model where one is cos, another is sine signal, both are having same frequencies. Only then you can apply that. Okay, and when both are causes are given in the phase part, causes maximum value we can figure out easily. Here beta can be figured out easily. If you can figure out beta, if they have asked you maximum frequency deviation here, maximum frequency deviation, don't try to find Fi here, because if you find Fi, you'll differentiate this cos, it will become sine. It is difficult to figure out the maximum value of sine. So don't try to go for instantaneous frequency in this case, because you are able to find out beta easily. There is no need to figure out del f from the basics. You can use the formula beta times fm or beta times bandwidth of message, just 14 times. What is the bandwidth of the message here? 1 kilohertz. There are two frequencies in the message, 1 kilohertz and 0.5 kilohertz. Highest frequency is 1 kilohertz, that is the bandwidth. So just 14 kilohertz is the frequency deviation. So you can figure out the bandwidth also here, which is 2 times del f plus fm. This is 2 into LF is 14 kilo plus FM message frequency is 1 kilohertz, which is 30 kilohertz is the bandwidth. But I'm asking you only modulation index here, which is 14. So I hope I've cleared how to solve these kind of model of questions. If they have given both causes with the different frequencies, both sine with different frequencies, one sine, one cos with the same frequency. So you might ask me, sir, what if they have given one cos and one sine with different, one cos and one sine with different frequencies? That they will not give, because it will be very difficult to figure out the maximum value there. One cos, one sine with different frequencies, it's not possible to figure out the maximum value just by looking at it. There will be some maximum value, but manually by looking at it, it's difficult to figure out the maximum value. So that kind of questions they will not give us. The questions, they'll give us the questions which we can figure out easily. You should be able to figure out the maximum value of a signal, right? So I have given some very good question here. I've given how to solve a model of questions here. So if there is any confusion, just go through this part of the class again. Around 10-15 minutes of this class, just go through it once again. My old students are there, they know how to solve this problem because I've discussed it multiple times earlier, but this model is little tricky. So in many other textbooks, many other books, other materials, and from many different institutes, they are confusing. They are confusing. Many people are using different formulas for different questions. Don't use that. Just use the basics that I've told you in this class. Definitely, I'll share every time I take a YouTube class. Immediately after the class, I'll be sharing the PDF. Okay, you can access it. Don't worry. Fine. So this is the toughest model in FM modulation, and this is a model that which even I got confused initially, because multiple solutions are given in multiple places. Connodia is giving some solution, some other is given some other solution. But I want a solution which we can get using our basics only. Okay, not we can't use fancy formula for every new question, right? So even if we use new formulas also, we can't remember them. So that's why my intention is to go from the basics. Any question we should be able to solve from the basics, right? So try to revise this part of the class if there is a confusion. If you have understood, that's fine. But if there is any slight confusion, just go through this part of the class again. It will be clear. Next, last 3 questions. Let us solve it. They'll take hardly 2-3 minutes, not more than that. We'll wind up the class in the next 10 minutes. Come on. 3 questions based on receivers. Simple questions. Receivers, you just need to understand the question carefully. Okay. So I'll quickly revise while you are solving the question. I'll just revise a few things here. In receivers, the first block will be tuned circuit. I'm talking about analog communication receivers. First block will be tuned circuit. Next is mixer. This is mixer. Mixer is like a multiplier only. So local oscillator. And after that, we have IF amplifier. So this tuned circuit will allow only the signal that we are interested in. So whatever channel we want to listen to, that channel this will be tuned to. So local oscillator frequency can be FC plus IF, or it can be FC minus IF also. Which one will be taken as local oscillator frequency? That information will be given in the question. So local oscillator frequency can be this or can be this also. But if local oscillator frequency is FC plus IF, then image frequency will be FC plus 2IF. When local oscillator frequency is FC minus IF, then image frequency is FC minus 2IF. Many people remember this generally. So generally this is taken practically. Local oscillator frequency is taken as FC plus IF. So practically image frequency is taken as FC plus 2IF. But that does not mean that local oscillator frequency cannot be taken as FC minus IF. In the question, they will be giving us information whether local oscillator frequency is this or this. Whenever local oscillator frequency is taken as this one, then image frequency is FC minus 2IF. You have to mind this. So how will that information be given? So one way of giving that is, so here the frequency of the message here is FC. So compare the frequency here and here. If local oscillator frequency is bigger than FC, bigger than FC, then we can understand that okay, they are using FC plus IF. When local oscillator frequency is less than FC, less than input frequency, then we can understand that local oscillator frequency is taken as FC minus IF. So like that, some form of information will be given. If there is no information, by default you can take local oscillator frequency as FC plus IF and image frequency as FC plus 2IF. So this is the quick revision on receiver. So without any filtering, a broadcast station at 1900 kilohertz. What station are we talking about? We're station at 1900 kilohertz, which means they're talking about FC, which means the tuned frequency we are tuning to this channel is heard together with another station. What does that mean? What is the other channel that we heard? So we are trying to listen to 1900, but we are also listening to some other channel. What is that channel called as? That is nothing but image frequency only, no? When we are trying to listen to one channel, some other channel also will be heard in the background if we don't design the receiver properly. But because we design the receivers properly, the second channel will not be heard. Don't worry about that. When we don't design the receiver properly, if we don't design this tuned circuit properly, that image rejection will not happen properly. That is when we listen to the image signal. So 2800 is image frequency. And what is the formula for image frequency? On a super heterodyne receiver. So they are asking us to find about IF. But they have not given us any information about whether they are using local oscillator frequency as FC plus IF. Did they not give, or have they given us? Have they given us or not given? They have given us, because FC is 1900 and image frequency is 2800. Image frequency is bigger than FC, which means they should be using this formula. Which means they have given us the information. They did not directly say whether they are using this or this. But from the data, we can understand that they are using FC plus IF as local oscillator frequency and FC plus 2IF as image frequency. So Fi is equal to FC plus 2IF. From the information, we can say that Fi is 2800 kilohertz and FC is 1900 kilohertz. FC is the channel that we want to listen to. Fi is the channel that we don't want to listen to, but we are getting it in the background. It's 2 times IF. So IF is equal to 2800 minus 1900 is 900, divided by 2 is 450 kilohertz. Answer is option B. Other question that could be asked here is local oscillator frequency. What could be the local oscillator frequency? Anyone? What could be the local oscillator frequency? It is FC plus IF, right? FC plus IF, because they are using image frequency as FC plus 2IF. So FC is 1900 kilo, plus IF is 450 kilo, and even there is 2350 kilohertz. I believe it is clear till this point. Very nice. Shall we move on to the next one? Come on, 20th question. A double tuned amplifier. Double tuned means two tuned circuits are used. Sometimes for better image rejection, whatever image signal that we are getting, if you want to suppress it more, generally we will be using tuned circuits. Image rejection is happening only because of tuned circuit, no other block. Sometimes we might be using double tuned circuits also, two tuned circuits also. And after that, anyway, mixer we get. And after that, we'll have IF amplifier. Okay. So if alpha 1 is the image rejection ratio for the first one, and alpha 2 has the image rejection ratio for the second one, then image rejection ratio for both of them will be given as alpha 1 into alpha 2. And I hope you know the formula for image rejection ratio. It is 1 root of 1 plus q square into rho square. But there's also same formula, 1 plus q square into rho square. Okay. Now let us do the question. So q is given as 100 for both the tuned circuits. There are two tuned circuits, it seems. So signal frequency is 100 megahertz. FC is 100 megahertz and IF is 10.7. FC is given as 100 megahertz and IF is given as 10.7 megahertz. Now the local oscillator frequency at the mixer, they're saying that local oscillator frequency at the mixer is greater than the incoming signal frequency, which is FC. What does that mean? They're giving us information that local oscillator frequency is taken as FC plus IF. Okay, if it was FC minus IF, this relation will not hold, right? So they will give this information somehow, in some way or the other, right? So find the image frequency of the receiver. What is the image frequency? Image frequency of the receiver is, we know from this given data, we have understood this is the local oscillator frequency. If this is the local oscillator frequency, image frequency will be FC plus 2IF, which is equal to FC is 100 megahertz plus 2 times 10.7 megahertz, which is equal to 100 plus 2 into 10.7 is 21.4, which is 121.4 megahertz. That's it. Very nice. The answer is option A, right? Why is it option B? Wait for a second. Okay. So it is 121.4. The question here is, yes, local oscillator frequency will be 110.7, but I'm asking you image frequency, no? Definitely local oscillator frequency is FC plus IF. Yes, that is correct only, which is 100 megahertz plus IF is 10.7 mega, which is 110.7 megahertz. That is fine. But the question asked is, find the image frequency of the receiver, which is FC plus 2IF, which is 121.4 megahertz. Is that okay? Any confusion here? Local oscillator frequency is 10.7, agreed. But I'm asking you image frequency. Fine, if you find other things that are not asked, that is also fine. But the answer is option A here. Okay. Fine. So I'll give you some homework also here. You can find alpha 1 and alpha 2. Alpha is equal to alpha 1 into alpha 2, which is equal to root of 1 plus q1 square, q square into rho square, into root of 1 plus q square into rho square. So generally q value is very big, so you can neglect this one and you can write as q into rho into q into rho. You can write it like this. Okay, so which is equal to q square into rho square. Approximately the answer will be q square into rho square will be the answer for alpha value. So where rho is given as image frequency divided by carrier frequency minus carrier frequency divided by image frequency. You can use this formula to find rho and substitute it here to find the image rejection ratio alpha. When there are two tuned circuits, find the image rejection ratio first tuned circuit and second tuned circuit and just multiply them like this. If there is only one tuned circuit, just find the image rejection ratio of that one by using root of 1 plus q square into rho square. That will be the answer. Okay, you can you can do the calculations and find the alpha value here in this problem. You can do it as a homework. Okay, I'm moving on to the next question. Any confusion? Just watch this part of the question again. YouTube video will be available, recorded will be available. Last question of today's class. Okay. What is 1523, Surajit? Okay, final answer. Okay, good, 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 good. I think in this question I'm asking you the same. That same question I'm asking you different things here: image rejection ratio and local oscillator frequency. Local oscillator frequency, you've already told me the answer, which is FC plus IF, which is 100 megahertz plus 10.7, which is 110.7 megahertz. There are two options with that, A and D. So how about alpha? Alpha equal to alpha 1 into alpha 2. We have approximated it as Q into rho into Q into rho approximately. Okay, just for easy calculations, you can do that. Instead of using calculator, you can do that. So what is rho value here? Fi divided by Fc. You can quickly calculate. I think already some of you have calculated it. What is the image frequency? Earlier we have done it. 121.4 divided by 100 minus 100 divided by 121.4. Can anyone tell me how much is this? 1.214 minus how much is this? Can anyone tell me how much is this value? Come on, come on, come on, make it quick. Answer should be around, definitely A should be the answer, because it can't be such a small value 39, because it is Q square is 100 square into rho square. 100 square is 10,000. Okay, this is 0.39. Huh? Okay, definitely. So this value, this is 0.39. When you square it and multiply with 10,000, it will be roughly around 1521. You have to use the calculator for calculating rho square. Okay. Yeah, thank you, Kishan. Thank you, Surajit. Yes, Rama Devi, definitely. You can. I'll be posting it on my Telegram channel, Telegram group. You can search with my name, Electronics by Dinesh Gutha. You'll get the channel. In that channel, I'll be posting immediately after the class. Okay. I hope it is clear. So we have found the alpha value, which is 1521. So that's it. I've covered generally recurring models. In some concepts, I've discussed a little bit more tricky questions also. So I think with this, you can judge your preparation on analog communication. If there are any pitfalls, if you are lagging in any concepts, just go and revise them. And any problems, if you are finding difficulty, just watch that part of the video. You can watch it again and get more clarity. Wherever there is a difficulty, I've spent some time and explained the concept wherever necessary. So this video will be always available on YouTube. You can make use of it whenever necessary. Okay, so all the best for your preparation. Next 1 week is very crucial, so try to revise the concepts. Don't lose your confidence. Okay, remember how much effort you have put in the past. That effort will count. It will show up in the marks. Okay, don't get tensed. So sometimes when you are not able to solve the question or not able to get marks in a mock test or grand test, you'll be demotivated, definitely. But that does not mean that final result will be same as that. That does not mean that some days we will not be at our best. So don't judge yourself based on the result on those days. Okay. So dark light, yeah, I mean, so if you are following my Telegram channel, definitely I'll update you. So even the team has not updated me what will be the next class, what topic will be the next class on. So but definitely I'll be taking, definitely in 1 or 2 days I'll be posting the class schedule in my Telegram group. And one more thing is, you'll be getting the updates on YouTube also. Whenever I take a class, you'll be getting an update on the YouTube also. 1-2 days before itself, you'll get the update. Okay, you can follow the channel, you can subscribe the channel, and you can follow. Then you'll get the updates. Okay, so I hope this class is helpful. So if you feel this class will help any of your friends, you can share it with them also. So that's it, guys, from my side. Definitely, man, definitely I'll try. Okay, I'll try. So based on the team decision, I'll definitely take, if they are willing, if they want me to take it, I'll definitely take it. Okay, so I'm not the decision maker here on what I should take and what I should not take, but definitely I'll let them know that you people are interested in that part, So if they wish me to take it, I'll definitely take it. Okay, fine then. Thank you. And very nice. Some of you have performed amazingly well. So keep up the same confidence, keep up the same confidence, and try to perform in the exam also at the same confidence. You'll get the best result possible. Okay, all the best, guys. Have a good day. Have a good week. We'll be having a lot of tension, pressure. Definitely enjoy that pressure also, because this kind of pressure and tension you'll not get. You'll get them very rarely. So these are rare instances where you should be we should be fortunate. Okay, not everybody will get this kind of situations, because not everybody will put this much of effort, right? Because we have put so much of effort in the last 1 or 2 years. That's why we are feeling a little bit tensed. We are worried about what result we will get. That's fine. That's completely normal. Everybody will be going through this phase. So enjoy this phase. Very crucial phase. All the best. May God give you strength, mental strength and physical strength, um, to perform in the exam very well. So I wish you answer all the questions that you know correctly, and may I wish you get the best result that you deserve. Thank you.